Um, Good morning, everyone. Today we continue our workshop, which named Computational Linguistics, after a very fruitful yesterday working. I suppose we continue have very fruitful and useful communication and presentations. And today we are going to have more than 30 presentations, and it engage us be working all day. And our first section include four presentations. The reglement is following. Every presentation should take 15 minutes. This includes the time for presentation and the time for questions. If you would like to have more questions, you should present your presentation shortly. Yeah, if you don't have some questions, we can start. And our first presentation is towards cross-lingual transfer based on self-learning conversational agent model. And I suppose Alena Yurchenko, yeah, will present?
It's Alina Igorevna will present
Alina
this.
Igorevna, okay, I'm sorry, yeah. Alina Igorevna, Trofimova German, please. And I'm sorry, one moment. I kindly engage you, present yourself, introduce yourself firstly, and your affiliation, your organization, as for speakers and as for a person who would like to ask some question. Please, Alina Igorevna.
Yeah, one moment. Oops. The presentation closed, sorry. So I have been working for the department of, how is our department called? Evgeny Valerievich, help me.
Intelligent Computer Systems Department.
Yeah, for 5
Don't
years.
worry.
I have been teaching English and French, and now trying myself in this scientific research together with my colleagues. Sorry, don't know why the presentation disappeared. It closed.
Will you share the screen once again?
Yeah, one moment. I don't know why it has closed. I will reopen it.
Time. Don't worry.
Don't worry, no matter why.
No, it was okay, but it disappeared for some reasons.
You should share once again your screen.
Yeah. I open it, yeah, and then share. Very strange. But the fact, can you see it now?
Yes, yeah, we can see it.
And the slides change, yeah?
Yeah. Okay.
Okay, so I'm glad to present our research called Towards Cross-Lingual Transfer Based on Self-Learning Conversational Agent Model on behalf of my colleagues, Olena Yurchenko, Olga Cherenichenko, and Yevhen Kupriianov. In this work, the goal is to develop a model of conversational system that would be able to acquire knowledge on its own, learning in a dialogue with a person, and in the future to transfer this knowledge to a person. The idea of the project is creating the semantic core for the self-learning conversational agent, short form SLCA, that acquires knowledge through reinforcement learning, using didactic models in the dialogue with a person in a natural language. The solution of the said tasks lies at the intersection of artificial intelligence and machine learning methods with linguistic methods of semantic analysis and synthesis by means of meta-language of meanings. The implementation of the project lies in an interdisciplinary area, including natural didactics methods of learning foreign languages, the transfer learning in natural language processing. In our opinion, the results of this research will have an important theoretical and practical significance for each field of science, which we are representatives of. And as a case study, we offer to consider a learning foreign language due to the challenges of rapid mastering it and improving and maintaining skills in its usage, which are still unsolved nowadays. Today, in communication models in natural language, far from all the available potential is being realized. That is why, because most software solutions use only a small part of the features of the natural language structure, including semantics. That is why, in our opinion, the elaboration of linguistic support of computer systems using artificial intelligence capable of building and understanding text and speech in natural language is an urgent task. As children first study their native language in the process of natural language learning, in the dialogue, with parents, later they accumulate knowledge in other ways to express the meanings we need. Similarly, while studying a foreign language or a specific domain language, we use the created knowledge base, giving only a different form of expression to the meaning existing in the head. That is why, for creation of the basis for self-learning conversational agent, SLCA, training, we suggest to build such a model in which the meaning of situation would be preserved and their form of expression would be chosen according to the needs of the user. A good example of this can be found in transfer or cross-lingual machine learning models. Cross-lingual representation learning can be seen as an instance for transfer learning similar to domain adaptations. The domains in this case are different languages. Cross-lingual learning as a form of transfer learning can help us understand why it might be useful and when it might fail. So transfer learning is useful whenever the scenarios between which we transfer share some underlying structures. In a similar vein, languages share communalities on many levels, from loan words and cognates, on the lexical level, to the structure of the sentence on the syntactic level, to the meaning of words on the semantic level. Similarly, it is harder to transfer between languages that are dissimilar. However, when comparing the advantages and disadvantages of this method with the need to create and process large corpora of texts for a small professional task, for example, or a low resource language, this method definitely wins. It should be mentioned that the most famous example of successful dialogue systems today, GPT-3 by OpenAI and BERT by Google, are also built on the basis of the large language model, a natural language processing model that uses large amounts of text data to learn how to predict the further words and phrases in the given text. These models are usually trained on large data sets, such as text corpora from various sources, books, news articles, web pages, and social media, which significantly slows down or even blocks the process of system learning for low resource languages, for example. But even though the systems are used for various tasks nowadays. In the picture, we can see an example where, in response to the sentence, "I learned in a different way," the system only gives the apology, not the continuation of a human dialogue. So that is why they cannot be used in the most common communicative didactic methods of teaching foreign languages. And that is our main thought here. The goal of our project is to develop and to ground, that is important, to ground the self-learning conversational agent model based on an extended advanced language learning methodology and to provide a theoretical assessment of its capabilities. It is suggested that solving the problem of constructing a cross-lingual transfer enables the SLCA semantic core to use the general concepts, meanings, regardless of the language, culture, sphere of human activity, and in the process of further dialogue with the person. It will be possible to learn certain forms of meaning expression in professional, social, and other jargons, considering the situation. Thus, it becomes possible to apply the SLCA model to any language in any field of human activity. For example, robotics, manufacturing, medicine, psychology, education, social media, e-commerce, as well as obviously in teaching natural languages, which is our main goal. In order to develop and practically implement such a system that would support a natural human dialogue, the following tasks need to be solved. You can see them at the slide. So I won't stop here for a long time. From a linguistic point of view, the following methods are proposed to solve the task set. Semantic analysis and synthesis will be carried out from a pragmatic point of view, using the discourse analysis and logical semantic approach, which implies obtaining additional information to model the dialogue by transforming its sentences. That's it. The meta-language of meanings is modeled using mathematical methods in the form of knowledge graphs, using linguistic methods of simplification and paraphrasing. Learning experiments are carried out using didactic methods of foreign language teaching. Thus, the implementation of the project lies in the interdisciplinary field, as I have mentioned before. And in order not to be limited by resources of a natural language, we suggest a hybrid combination of unsupervised cross-lingual representational learning and supervised learning, a model through a human dialogue according to a language system model. That's it. Priority. Priority in our work is given to the transition from the meaning to the text. As we believe that a description of the text interpretation process can be derived from discourse analysis. I would like to imply that understanding language as a multi-level model implies that the generation of any speech process in a natural language based on a given meaning does not occur directly, but through a series of transitions from one formal level of representation to another. That is, from the morphological, grammatical level, through the syntactic text level to the semantic meaning level. Consequently, a self-studying conversational system can both store and the analyzed meanings derived from a human dialogue and synthesize them itself, which is really important for our project. As a semantic parser, we propose to use a model of transforming the syntactic structure of a query into a semantic one by means of conceptual graphs, which will be stored in the knowledge base in form of a formalized meta-language of meanings. Depending on which aspect depending on which aspect of speech activity is modeled, listening or speaking, functional models will be divided into analytic and synthetic ones. It is presented here in the picture. The dialogue exists within a context, and understanding that the context is crucial for building knowledge from a conversation. We want to emphasize that overall, to build knowledge from the context of a dialogue, it is important to pay attention to the history of the conversation, identify and track key concepts and entities, use external knowledge sources, and consider the social context of the dialogue. Capturing and saving the meaning of context over a dialogue requires a combination of NLP techniques, including contextual embeddings, attention mechanisms, memory mechanisms, and discourse analysis. By incorporating these techniques into the model architecture and training process, the model can better capture the nuances of language and generate more relevant and coherent responses.
Alina Igorevna, I am sorry, your time is over. Could you a little quickly go to finish your presentation?
Yeah, of course, I'm coming to the end. So as for expected results, we can see that based on the analysis of the current state of communicational system, we assume that advantages of the proposed self-learning conversational agent model will be faster process of learning, both for machine and people, easier fine-tuning to a particular language or domain, clearer representation of the same meaning, and reducing the number of examples which are needed to train the model. Conclusions. The novelty of the proposed model self-learning conversational agent is to create a machine learning model similar to a natural communicative didactic model that takes dialogue in a native natural language as a template for self-learning and then can be used as a simulator to teach a person a foreign natural language or its social or professional dialects. And the other points are included. That's it. Thank you for your attention. Have you got any questions?
Thank you very much. We don't have time for questions, but if someone has some brief question, please. In order to ask something, you can use the up hand on the bottom of your screen. You can use your voice, and of course, you can use our chat, please. I have some small question, but we don't have that. Alina Igorevna, you say about the technology cross-linguistic transfer learning, and it's technology, as you described, transfer from different domain and different language. What different language, what different domain do you suppose to use or use?
As for languages, that can be any natural language, which is, for example, popular now, like English, French, German, Spanish, whatever, Turkish, Chinese. Well, I don't know about Chinese. I need to ask my colleagues. And as for the main language, that is the language of particular sphere. Yeah, I have mentioned different professional jargons or social or something like that.
Okay, thank you. Thank you very much.
Can I say?
Okay, of course, but we don't have time, please.
Ask question.
Est-ce que je peux parler? Alors,
You would like to ask question, Alina?
Yes.
Okay. Alina is a co-author of this presentation.
Okay, mais
okay, please, Ed.
I will. One second. I wanted to add that we're supposed to transfer from high source languages to low source languages. That's technology of transfer learning. They add to do that transfer. Because the technology of corporate texts it's more difficult for us.
Okay. Yeah, thank you, Alina. But I suppose you know what particular language you supposed to use. But yes, you describe the general theory. I understand. Thank you.
Okay.
Thank you very much. Thank you. We don't have any other questions. Thank you for a very interesting presentation. Close, please, your presentation, and then we should go to next to continue. The next presentation is calculation of the semantic distance between ontology concepts, taking into account critical notes.
Thank you. Now
Please,
I share my screen. Do you see my presentation?
Yeah, yeah, we can see.
I'm associated professor of Department of Information System and Networks in Lviv Polytechnic National University. And I am glad to present my presentation. Title is on the slide, and go on. Tasks related to the semantic analysis of textual information do not lose their relevance. Some of these tasks displayed on this slide, and when implemented the method of inverse additive matrix, some difficulties associated with critical nodes on the passes in the directed ontology graph from one concept node to another appear. Critical nodes are intersection nodes, merge nodes, and branch nodes. The presence of such nodes requires additional analysis of the ontology graph and additional calculation to correctly calculate the semantic distance between ontology concepts. On these slides, some kinds of related works are displayed. These works are those that constructed the matrix containing the number of words per document. Second, the studies of scientific texts based on the previously constructed corpus of citations, and semantic analysis based on the semantic orientation of vocabulary, and so on. These and many other works do not take into account the possibility of the existence of many paths from one ontology terms to another. The problem is explained later. Inverse additive matrix for the ontology concept. By analogy with electrical resistance in parallel and series connections, the inverse additive matrix determines the distance R between concepts A and B as follows. See formula 1, where Ni is the number of transitions from concept A to concept B along the ith path I from 1 to K. K is the number of different paths that can be taken along the directed graph of a certain ontology form, concept A to concept B. If there is a single path between concept A and B, then the distance between them is equal to the number of transitions from one concept to another, formula 2. Thus, the more paths exist between concepts, the smaller this distance will be. That is, the semantically closer and corresponding terms will be. Critical nodes of the ontology graph. Consider the case depicted in figure 1. Node E is the intersection that is critical on the way from A and B. Then the formula of calculation distance between concept A and Y represented on this slide. Critical nodes E on figure 2 is a match that is critical from path from A to I, and the figure 3 displays case that the node E is a branch node, is critical on the path from A to I. Therefore, in order to obtain the correct values of semantic distance between ontology concepts, it is important first to identify critical nodes, intersection nodes, matching nodes, and branching nodes. Secondly, to use the correct algorithm for calculating the semantic distance in the presence of critical nodes. Presentation of concepts of the ontology of terms in the form of a list of adjacent vertices and identification of critical nodes. The directed graph ontology of terms can be represented as a list of adjacent vertices. It is easy to see in the case of match nodes, the critical nodes is an intermediate node that acts as a receiver more than once. For example, from B to E and from D to E. For a case of a branching node, the intermediate node that is source more than once will be critical from E to F and H. For intersection, for an intersection node, both conditions are true. Such a critical node is an intermediate node from simultaneously acts as a receiver more than once and is a source more than once. Therefore, to identify critical nodes, it is enough to look at the list of adjacent vertices from the initial nodes A to the final nodes I and find out whether there are intermediate nodes that are sourced and or receivers more than once, as explained this picture. In the presence of critical nodes, the direct application of formulas 1, 2 to calculate the semantic distance between concept terms of the ontology leads to an incorrect result. In this case, one should use the method of calculating the equivalent resistance with a series parallel connection of resistors. Such method of calculation displays on the slides. The algorithm of the test program for finding critical nodes of a directed graph is as follows. First, a directed graph is randomly generated, which is represented by adjacency matrix. Based on the adjacency matrix, a list of adjacent vertices is formed. Critical nodes are searched for in the list of adjacent vertices. For this purpose, the with-search algorithm is used. To verify the correctness and effectiveness of the developed algorithm, test data should be generated. These inputs are directed graphs generated using a random number generator. These graphs will model ontologies of terms, vertices correspond to concepts, and edges correspond to connections between concepts. A direct graph which corresponds to the relationship between the concept of the terms ontology should not have loops and cycles. The adjacency matrix of such a graph should be sufficiently sparse. The number of ones should be significantly less than the numbers of zeros. To form a sufficiently sparse adjacency matrix, in which the number of ones is much smaller than the number of zeros, we use the following approach. The code is on the slide. The element of matrix randomly get the value 1 or 0 with probability 1 over n and n minus 1 over n, respectively. The value n equal to 3 was chosen for testing. In order to graph not to contain loops, the main diagonal of the adjacency matrix must contain only zeros. This approach. Finally, to eliminate cycles consisting of two vertices, consider the element located above the main diagonal. If the element Mij has the value 1, then the value 0 will be assigned to the element Mji as such. Cycles that pass through a large number of vertices are much more difficult to detect and eliminate. Therefore, this test program does not perform such operations. The algorithm of forming the list of adjacent vertices from the adjacency matrix is well known and does not require comments. Processing the list consists of finding all paths from one given node to another and checking whether these paths share any nodes other than the start and end nodes. To search for these paths, the search method was used. which also needs to explanation. Results. A test program was created for finding critical nodes of a direct graph that models the ontology of terms. Vertices correspond to concepts and edges correspond to connection between concepts. The performance of these test programs has also been tested against predefined directed graph when the input is a text file containing a list of adjacent vertices. The result of the test examples confirms the correctness of the developed algorithm. Discussions. The detection of critical nodes in itself requires additional time compared to the direct application of formulas 1-2. If the check confirms the presence of critical nodes, then the correct calculation of the semantic distance leads to the need to solve the system of equation according to the chosen method. For example, method of contour of nodal equations. Naturally, the question arises, is it worth doing all this? Or would it be better to use some other less accurate but faster method? First of all, it should be noted that the proposed inverse additive metric has its own field of application, namely term ontologies. Usually, the ontology of the terms of a subject area hardly changes. After the ontology is formed, the addition of new concept and connection between them occurs only with significant changes in the terminology of the subject area. Thus, it is possible to significantly speed up work out the calculation of the semantic distances if first ignore terms located for enough away, for example, farther than 5-7 transitions from the given term. Second, create the map of semantic distances to the nearby nodes. This method will require additional parameters for ontology graph. Each node must additionally contain data about these semantic distances. Conclusion. This work develops a semantic analysis method based on an inverse additive metric that describes the semantic distance between ontology terms. The inverse additive metrics allow us to correctly process cases when there are several paths in the directed graph of ontology from one concept node to another. The work describes ways to overcome some difficulties in the implementation of this method, associated with critical nodes of the path in the directed ontology graph from one concept node to another. Critical nodes are intersection nodes, merge nodes, and branch nodes. The presence of such nodes requires additional analysis of ontology graph and additional calculation to correctly calculate the semantic distance between ontology concepts. These are references, and thank you for attention.
Thank you very much, Victor. Thank you very much for a very useful presentation. Any questions? I see Elena Nikolaevna questions in the chat. Elena Nikolaevna, can you read yourself?
Yes. Tell me, please, how many concepts can be described with that technology of ontological graph? Because it's the question of difficulty to describe the semantic.
Comprehensive.
Now I'm modeling the concept graph randomly generated matrix, and existing ontology contains thousands of concepts that will be useful to calculate the semantic matrix between concepts. Then the ontology of terms contains many paths from one concept to another, and this approach is useful to correctly calculate the semantic distance between them.
Okay, I see. Thank you.
Thank you very much. Do you have any questions? Some other? No? Thank you, Victor. Thank you.
Thank you. Sorry, I must go to my lectures and I log out from the meeting.
Yeah, Yes,
Thank
yes.
you.
Have a good day. Thank you. Thank you. We continue. We go. Our next presentation that we would like to hear is analyzing the accuracy of speech-to-text APIs in transcribing the Ukrainian language.
Yes,
Who
hello
would like to
colleagues. So
present?
let me share my screen.
Yeah, please.
Yeah, do you see my screen?
Yeah, we can see.
Okay, so hello colleagues. I'm Laszlo Kupriianov, a student of National University Lviv Polytechnic of System Analysis stream, and I'm happy to be here today to share some experience and insights with all of you. So in my time as a student, I have the opportunity to explore my passion and interest, including information technologies, business analysis, and integration IPs in real life programs. So one of my main interests is discovering new ability of information technology to support Ukrainian language. And I've been fortunate to have some exciting experience in this area. So this has not only depend on my knowledge and understanding of speech-to-text technology, but it has also given the valuable skills and perspective that I can apply to other areas of my life and work. So in my presentation today, I'll be sharing more about my experience and insights in accuracy of speech-to-text APIs in transcribing of the Ukrainian language, including some of the challenges I faced and how I overcome them. So I hope that my experience will inspire and inform all of you. Yeah, we start from the first part, the introduction part. And in this part, I want to say that speech-to-text technology is becoming increasingly important in Ukrainian as digital infrastructure expand, but accuracy in transcribing the Ukrainian language is critical for communication, education, and access to information, especially in the wake of Russia invasion. This research aims to analyze the accuracy of various speech-to-text APIs in transcribing of the Ukrainian language from voice to text. Using a diverse set of audio input data, we evaluate the API's accuracy in terms of word recognition and sentence level transcription and compare their performance to manually transcribed text. So this presentation provides the comprehensive overview of the latest development in speech-to-text technology related to Ukrainian language transcription, some methods used in the analysis and the results and their implications. So speech-to-text technology has rapidly advanced in the recent years, making it easier to convert spoken language into the written language. While this technology has been widely adopted for English and other commonly spoken languages, there has been less research into its accuracy for less commonly spoken languages such as Ukrainian. So in this article, we analyzed the accuracy of several STT applications program interface of the Ukrainian language. If we said about the goal of our research, so the goal of this research is to analyze the accuracy of different speech-to-text APIs in transcribing of Ukrainian language. To achieve this goal, we will be conducting a series of experiments using the variety of APIs and comparing their performance to manually transcribed text. So if we want to start with the analysis of the similar works, and some of them is, I want to start that speech-to-text technology has been the subject of extensive research in recent years, and there has been several studies examining the accuracy of different speech-to-text APIs in transcribing various languages. However, relatively few studies have focused specifically on Ukrainian language transcription, making this a valuable area for research. So the one studies which was on 2019, where was analyzed the performance of STT APIs for the Greek language. So they found that the accuracy of the APIs varied significantly depending on the complexity of the language and the quality of the audio input. The second study took part in 2020, where was evaluated the accuracy of STT system for the Bengali language. So they found that the performance of the system varied depending on factors such as speaker accent, background noise, and the percent of field words. And the third studies was discovering in 2021, where was analyzed the accuracy of STT APIs for the Pashto language. So they found that the APIs has relatively low accuracy, especially when dealing with complex sentences and unfamiliar vocabulary. In comparison of these studies, the current article focused specifically on the accuracy of STT APIs for the Ukrainian languages, like the affirmation studies. It evaluates the performance of these APIs based on various factors such as language complexity and background noise. So, however, the studies is unique and in its focus on the Ukrainian language, which has received less attention in the STT research community. But one studies examination in the Ukrainian language transcription was conducted by a group of researchers at the National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. So in these studies, the researchers compared the accuracy of the 3 different speech recognition systems in transcribing the Ukrainian language. The study found that all 3 systems performed well, with an overall accuracy rate of 88 for the best performing system. However, the studies also noted that the system tended to struggle with proper nouns and words that were not in the system vocabulary, so suggesting that there is still room for improvement in Ukrainian language and transcription technology. If we talk about the methods and experiments which we was using in our experience in the future. So one method of the recognizing the Ukrainian language is to use the neural networks, which are trained on the large data sets to recognize the classified text. For instance, recurrent neural networks can be used to analyze word sequences and make decisions based on context. Another method is the use of natural language processing (NLP) techniques, which allow the analysis and understanding of linguistic structure. For example, methods for constructing syntaxis trees can be used to analyze sentence structure and relationships between words. And another method is use of deep learning and machine translation, which allows for the conversation of speech to text and vice versa. For example, translation models can be used, which are trained also on the large data sets and capable of automatically converting text from one language to another. Here we have the table which shows the advantages and disadvantages of this method. So some works well with sequence of work and can learn on the large data sets. Some can work well with complex sentences and etc. If we go on and talk about the techniques, which we would like to use, or just to be familiar with them. So the first one is transfer learning. The transfer learning is a machine learning technique that involves training models on one task and then applying that model to a different but related task. So in the context of speech to text, transfer learning could be used to train the model on a large corpus of spoken to text, and trans learning could be used to train the model on the large corpus of spoken, for example, English language, and then fine-tune the model on a smaller corpus of spoken Ukrainian language. So this approach had the potential to improve and the accuracy of transcription, be leveraging to knowledge learned from the English language to better understand the Ukrainian language. The second one is speaker diarization, is a process that involves identifying who is speaking in audio recording. So in the context to speech to text, speaker diarization could be used to separate, multiply speakers in a recording and transcribe their speech separately. So this approach had the potential to improve the accuracy of the transcription by allowing the speech to text APIs to better model in the unique characteristic of each speaker's speech. The third one is contextual information. Contextual information, such as topic of the conversation on the background of the speakers, can provide additional information to add the transcription of spoken language. So in the context of speech-to-text context, information could be used to improve the accuracy of the transcription by providing additional context for the speakers to text IP. The next one is acoustic modeling. Acoustic modeling is a technique that involves training a model to map acoustic features of speech, such as frequency and amplitude, to be corresponding phonetic units of the language. And a fifth one is language model adaptation. So it just model adaptation involves fine-tuning and pre-existing languages model of a specific domain or data sets. And the last one is pronunciation modeling. So pronunciation modeling is a technique that involved modeling the phonetic variation in speech, including the variation in the pronunciation of different speakers, like accents and dialects. So in the context of speech-to-text, pronunciation modeling could be used to improve the accuracy of the transcription by better modeling the different ways. The next one, we talk about the experiment. For the experiment, we use the data of spoken Ukrainian language samples, which was collected from various sources, such as public speeches, radio programs, interviews. So the data set contains of 500 audio files, short audio files, which each file begin approximately 5 minutes in length, for a total of 2,500 minutes of audio data. And the experiment aimed to compare the accuracy of different speech-to-text IPs using precision, recall, and F1 score metrics. So 3 widely used established speech-to-text IPs were chosen for the experiment. First one is Google Cloud speech-to-text, second is Amazon Transcribe, and Microsoft Azure Speech Services. Each IPs use different algorithms and techniques for speech recognition, providing a diverse set of tools for the analysis. So to compare the accuracy of the IPs, each audio files was transcribing using all 3 IPs, and the resulting transcription were manually varied for accuracy. If we talk about results, it's more about it. So about the results. Based on the precision, recall, and F1 scores obtained for the experiment, we can draw some conclusion about the accuracy of 3 speech-to-text IPs tested. So Google Cloud Text had the lowest accuracy with a precision recall and F1 score of 0.4. This means that only 40% of transcribed samples were correctly transcribed, and only 40% of the ground truth samples were correctly identified in the transcription. On the other hand, both Amazon Transcribe and Microsoft Azure Speech Service had higher accuracies than Google Cloud Speech-to-Text, with both achieving precision recall and F1 score of 0.8 and 0.75. So the table 2 showed the precision recall and F1 score for each of these speech-to-text IPs. The precision, what is a precision? Yeah, so precision is a ratio of the correctly transcribed samples to the total number of transcribed samples. The recall is the ratio of the correctly transcribed samples to the total of number of ground truth samples. And F1 score is a harmonic meaning of precision and recall. So as shown in the table, Amazon Transcribe and Microsoft Azure Speech Services have significantly higher accuracy than Google Cloud Speech-to-Text, with both achievement in precision recall and F1 score. The figure 1 showed that comparison of precision recall and F1 scores too. Overall, the experiment demonstrated the importance of comparing the accuracy of different speech-to-text IPs when selecting one of a specific application. It also worth noting that the accuracy of speech-to-text IPs is highly dependent on the quality of characteristic of the audio data, as well as the language being transcribed. So therefore, it's important to carefully consider the requirements of the application and the characteristic of the audio data before selecting a speech-to-text IP. Let's move to some conclusion part. Yeah. And based on the results of the experiment, it can be concluded that Amazon Transcribe and Microsoft Azure Speech Service are more accurate than Google Cloud Speech-to-Text in transcribing spoken Ukrainian language samples. The experiment also demonstrates the importance of comparing the accuracy different speech-to-text IPs when selecting one for a specific application in the future. It is important to carefully consider the requirements of the application and the characteristic of the audio data before selecting a speech-to-text IP. The accuracy of speech-to-text IP is highly dependent on the quality of characteristic on the audio data, as well as the language being transcribed. However, precision and recall scores for Amazon Transcribe and Microsoft Azure speech servers were significantly higher than those of Google Cloud speech-to-text, including that these two APIs are better suited for transcribing spoken Ukrainian language samples. So the result of experiments are consistent with previous research that was shown that different speech-to-text APIs have different levels of accuracy. For example, a study conducted by Google in 2017 found that its speech-to-text AP had the same word error rate. So another study conducted by the University of California found that the accuracy of different speech-to-text APIs varied depending on the type of audio data that being transcribed. So that's it for my side. Thanks for watching and listening to this presentation.
Thank you for your presentation. Do you have any question, please? I have a question. I am wondering what technology do you use to calculate especially recall or precision, because in order to calculate it, these coefficients, you need first of all spoken annotated corpus or some expert. What technology do you use?
So it was quite easier to do because we have these three APIs to recognize our text, and for all of this audio we write handmade transcribing. So as we listen, we write that, for example, someone was speaking on the TV and we said, give me some money, yes, if you say in English, but APIs can recognize it in another way. So we create the first transcribing as handmade, and then three another was transcribed by APIs. So that's why we compare it word by word using, so the first word compared with the first word of the second piece. Then we compare the first word from our handmade written transcribing for the first word of second NP, and that's why we use this data.
Yeah, but in order to this technology be reliable, it's necessary to more concrete describe it. It's you can see we can see two experts or three experts, and then you compare, because this available of these coefficients, it's similar. It's a little strange. You understand me? Because you describe how you calculate precision. It's not recall. Yeah.
So in my paper is the code of in the program language, so you can
More correct.
Yeah. So you can see the calculation.
Okay. Thank you very much for your presentation.
Thank you.
If nobody, yeah, thank you. And we go to our last presentation of this part of our workshop, Solomia. The presentation is creating a model of war and pandemic apprehension, textual semantic analysis. Appreciation. Please.
So, dear participants, I am Solomia Albota, and I am Associate Professor at Applied Linguistics Department at Lviv Polytechnic National University. Let me share my presentation. So once again, the paper is entitled Creating a Model of War and Pandemic Apprehension, Textual Semantic Analysis. Well, having studied multifacetedness nature of social networks for a couple of years, we encounter the tendency in its social affordance. Although semantic process has become one of the most studied areas within social media, we cannot do without analyzing such linguistic factors of media affordances as cultural, social, as well as cognitive perceptions of utterances. In our case, the attention is paid to the linguistic nature of social network comments regarding semantics of war and pandemic notions. The chosen material for the research is Reddit media,
To reveal the hidden or visible attitudes toward social commenting upon war and pandemic concepts is of importance, as the purpose of the study is to create a general model of war and pandemic apprehension through application of semantic analysis of the Reddit post comments and allocating their semantic groups. Emphasizing the mutual correspondence between action and speech, we claim that what a user intends to say presupposes his future course of the follow-up actions and vice versa. Speech acts correlate with verbal messages being uttered either online or in real, thus providing this communicative meaning for sense. So the methodology encompasses linguistic reveal of the degree of war and pandemic apprehension, applying textual semantic analysis to the Reddit social media comments. So here's the analyzed Reddit war post with the biggest amount of comments. We analyzed 576 text fragments and linguistic markers of implicit or explicit nature of utterances, followed by linguistic interpretation and the type and subtype of particular communicative action. Then the last stage of the methodology is the application of a software toolbox. It's called LIWC22, which certifies authenticity of the linguistic results obtained by textual semantic analysis. The same procedure concerns the Reddit war post with the least amount of comments. This time we had 579 comments. So these analyzed Reddit comments with their most and least amount refer to submodal war implications of our general linguistic and cognitive model. The same methodology was applied to the most commented Reddit pandemic post and the least commented pandemic post under the second linguistic and cognitive submodal, pandemic consequences. And the same results by this LIWC22 software. So here we provide arithmetic mean of percentage concerning the Reddit semantic groups of two linguistic submodals, war implications, WI, in the first line and pandemic consequences in the second. The result of comparison is that such military unawareness and doubts concerning both sides of war participants are shaped by cognitive mechanisms of war perception. And a general model of war and pandemic apprehension is based on two submodels, which are shaped by theory of speech acts, representatives with statements, subtype, and verdictives with negative assessment towards utterances of other users, appraisal subtype, were widely applied. Such an application of almost all types of verbal actions indicates multifold semantic nature of Reddit users' statements shaped by both social and cultural affordances. So we may state that without appropriate cultural background, online users fail in tendency of commenting, thus causing discomfort conditions for discussion among others competent users. In other words, the semantics of positive deeds for Ukrainian glory and victory cannot be identified with users' military unawareness. So these are the outcomes of linguistic interpretation of war implication submodal of the most commented Reddit war-oriented post. What concerns the least amount of commenting, still this war implication submodal, when one country gains more foreign support, that much dissatisfaction our enemy receives. So only two interpretative linguistic results we obtain concerning second pandemic consequences submodal, as all textual fragments analyzed are considered negative without exceptions. So users were mostly dissatisfied with ongoing mask regime in some public places and job losses due to virus restrictions. And finally, mutual connection between war implications and pandemic consequences submodals is established. They both imply consequences of linguistic, social, as well as psychological, cultural, and cognitive phenomena. Pandemic is considered one of war manifestations, as it is a powerful weapon, of course in a figurative way, against humanity, At the same time, war triggers world calamities, and pandemic is one of its biggest levers. So in conclusion, the complex linguistic methodology of shaping linguistic cognitive perception of the Reddit war pandemic comment relation was introduced. The pandemic with its consequences is considered one of the harbingers of war with its implications, the initial stage of world chaos, and war with its implications undermines pandemic recovery process. And in perspective, the semantics of Ukrainian victory in Russian-Ukrainian war and its linguistic cognitive mechanisms may be studied and developed in further scientific exploration. Thank you so much for your attention.
Thank you. Any question to Solomia? Solomia, you shown us the table on the slide 12. It's about some positive and negative tone. Can you explain how you decide how you calculate the positive and negative?
So first of all, we calculated all these, I would say, manually, indicators of our Reddit comments. And then we use this LIWC program, this software tool. So it proved these indicators we previously analyzed. And in these columns, we compared our results with the social media average indicators. So here we just made arithmetic.
You manually decide where it's positive, where it's negative.
Manually, firstly manually.
Yeah.
And then program.
The same approach to the social words, yeah?
Yeah.
Social words, yeah?
Social words.
You have some list of social words, yeah?
Yes.
Thank you very much.
Thank you so much.
Some other question? No, thank you. It's not very active audience today. Yeah, thank you everyone. Now we finished our first part of our computational linguistics workshop for today. And next part will be after the coffee break. It's 10:15, and I pass my moderation to Yevhen Valeryevich.
No, to Alina.
I don't know. It's necessary to
Alina Igorevna. She
Yeah,
will
to
Alina Igorevna. Yeah, to Alina Igorevna. I happy to pass now right to Alina Igorevna. And thank you for all, and have good day and very interesting workshop.
Thank you so much.
Go on.
Thank you.
Yeah. Thank you. But I don't know. It's necessary to disconnect or should connection today.
No, it is necessary to disconnect.
So we wait for 15 minutes, or we continue?
Yes. Do you have a program?
We have break now. We have break now,
break
and
now.
then we'll connect after 10:15. Yeah.
15.
Okay, so we have a break for 15 minutes.
Yeah. See you.
Okay.
Thanks.
Thanks.
Thank you.
So we continue our listening to the reports, and the next presenter, I think that is Dmytro Mohlevsky. Are you? Let's ask. Because I can't see anyone else from this group of authors. Oh, no, Anton also. Anton, is it you who presents the report? No.
Yes, I'm from this group, but I'm not presenting.
Who is the presenter? Can you please help us?
I will ask for one minute.
Yeah, okay, please. Because we can see you in the program, but don't know who is the presenter. The article is called A Conceptual Text Classification Model Based on Two-Factor Selection of Significant Words. And there are 5 authors, co-authors. So we are waiting for a while. Or Evgeny Valeryevich, should we pass to, but I can't see.
If in a minute there won't be some response,
yeah, there appears.
We'll skip this.
Yeah, we can see Vladislav. Vladislav, are you the presenter?
Yes, sorry, Zoom decided to update and didn't let me in.
Ah, I see. Okay,
Until I finish.
you're welcome to start. Present yourself in brief, and you're welcome to start your report.
Yes, okay. Wait a bit. I'm opening my presentation.
Okay.
Yes. Okay, Collins. There we go. All right. Now presentation. All right. Can you see my screen? All right. So, good afternoon. My name is Vladislav Kholev. Today I represent Kharkiv National University of Radio Electronics. The presentation is devoted to one of the possible approaches to determine topic-related words in a frequency dictionary, and the title is A Conceptual Text Classification Model based on two-factor classification of two-factor selection of topic-related words. This approach allows to increase the accuracy of text document classification from 2 to 4%. The content of my presentation can be expressed in the following points. It starts from introduction, including motivation, analysis of related works and main goals. Then I present the proposed conceptual model of text classification based on two-factor selection of topic-related words. Then we will focus on the quality assessment and of text classification model depending on the chosen feature selection method. Lastly, the presentation ends with conclusions. With the increase in the amount of textual information in electronic form, the task of automatic text classification continues to increase in relevancy. This task arises during the automatic process of news flow and distribution of news text in catalogs. See the figure on the slide for the details. The slide shows that the task of classification is especially important in the scientific field, where tens of thousands of monograms, articles, preprints, and other types of publications are being added annually in each of the disciplines. Effective processing of such arrays and the quality of searching for materials relevant to a particular research area require an accurate correlation of each publication with its thematic category for different languages, including Ukrainian. Thus, the research of the classification on the classification of text documents is a relevant topic in high demand. Modern research papers confirm the relevance of the text classification problem, which is based on generally accepted stages presented on the slide. All steps are sequential, related to each other, and equally affect the classification accuracy. In accordance with general classification model, the text is represented in the form of vectors, because it allows to consider text not as a set of tokens or symbols, but in a more computer-friendly way, in a form of vector. During the feature selection stage, the text vector is represented as frequency vectors of word occurrences based on TF, TF-IDF, CTF-IDF, or other schemes suitable to be solved by machine learning methods. However, the use of the entire vector is a redundant task, since not only it doesn't lead to increase in classification accuracy, but also makes processing time longer. Therefore, one of the ways to improve the general classification model is to define a rule for reducing the frequency vector of word occurrences. As the slide shows, many different methods can be used to solve the problem of classifying text documents. On average, the accuracy of various text classification algorithms varies in the range of 70 to 90%, and depends not only on the algorithms themselves, but also on the quality of the source data, as well as preprocessing methods. The aim of this work is to create a conceptual model of two-factor text classification on the example of standardized training and test text data sets. In order to accomplish the aforementioned aim, it is necessary to complete the following tasks: to make the overview of existing methods of text data. Excuse me, do you hear me? My internet seems to be unstable. Can you hear me?
Interruptions, but it doesn't prevent from understanding.
Okay, good. Okay, so as I was saying, the first task is to make the overview of existing methods of text data classification, then to analyze methods of preprocessing and preparation of the input text data, to develop a text classification model based on two-factor selection of topic-related words, to research the frequency vector reduction impact on the text classification accuracy, and finally, to analyze the obtained results. In order to achieve the noted scientific novelty, a study of the classification accuracy was carried out using different values of the occurrence of terms, as well as the different thresholds of words in the dictionary. By combining the performed studies, a modified method for determining topic-related words was proposed in a conceptual text classification model, increasing the classification accuracy by 4%, which is presented on the next slide here. The research proposes a conceptual model of text classification based on an accepted stages of the automatic text classification process, modifying the feature selection model. The method of topic-related words selection was improved by combining two factors: frequency measure and threshold of topic-related words in frequency dictionary. Achieving this goal was possible due to the analysis of the dependency of the classification accuracy of used datasets on the choice of topic-related words of the frequency dictionary built on the basis of the TF-IDF method. The aforementioned datasets include the newsfeed articles of Reuters 21578 dataset, the NCF dataset containing 129,000 abstracts for basic research, as well as a balanced mini NG20 dataset of messages on different topics containing many grammatical errors and misspells. In the first experiment, the classification accuracy using all words of the frequency dictionary was compared with the one using the value called the pruning level, or PL. This value indicates that terms that appear at least n times in the training set are used in the decision vector, while the rest are ignored. PL of 1 corresponds to AW method, that is, no pruning. We conduct experiments with 7 different levels of pruning, ranging from 2 to 30. 3 datasets were analyzed in terms of the micro and macro success rates for each reduction level. The first column of the table shows the method and the value of the PL parameter. As evident from the table, the reduction process improves the success rate of the classifier, with the best results, both high accuracy and low fission numbers, being obtained at the pruning level of approximately 13, consistently across all 3 datasets with 2 different performance parameters. In the second experiment, the classification accuracy using all words of the frequency dictionary was compared with one using 5 different numbers of keywords. AW includes all words in the decision vector. In general, AWK method with the number of keywords from 2 to 4,000 increases the success rate in all datasets compared to the AW. Therefore, it can be concluded that using a specific set of keywords for each class gives more successful results as opposed to using all words in the feature vector. When we analyze the results of the first and second experiments together, we see that the improvement of pruning level-based approach over AW is clear in the balanced datasets, such as mini NG20, while the improvements in the distorted data sets, such as Reuters and NSF, is smaller. On the other hand, the improvements of keyword number-based approach over the AW is more significant than the one of pruning level-based approach in all of the data sets. Hence, in the third experiment, the optimal pattern of two aforementioned approaches are combined. A pruning level of 13 and the number of keywords between 2 and 4,000. As the table shows, the two-factor feature selection approach with 2 to 4,000 keywords for each class with the initial reduction step significantly improves the best pruning level-based approach and keyword number-based approach performance in all three datasets, outperforming them. On the slide are presented the results of the proposed combined method of topic-related word selection. The result diagrams show quality assessment of three methods by micro-average and macro-average F-measure values for different datasets. The proposed combined method of two-factor selection of topic-related words performs at a higher accuracy than others, especially in the Reuters set by micro-average F-measure. Also, due to the heterogeneity of the data, we can see different micro levels and macro levels average F measures for different data sets.
Vladislav, sorry, can you please pass? Conclusions. Yeah, because the time is almost up.
Yes. In conclusion, in the course of research, a conceptual model of text classification based on accepted stages of the automatic text classification process with modification in the feature selection model was proposed. The detailed conclusions are shown on the slide. Further potential development will include using the proposed method in semantically oriented text classification system, as well as expanding the functionality in general. On this note, I end my presentation. Thank you very much for your attention.
And dear colleagues, have you got any questions, please? You're welcome to ask. No questions? Such a complicated research, probably. Some people need more intensive learning about that. Okay, thank you. I hope you develop that. Yeah, because really sensible model. Thank you very much for your presentation. So we pass to the next speaker, as there is no questions. Okay, I can see the speaker. What do we do? Yevhen Valeryevich,
let us keep this report and make it last.
Okay, then we can pass to Natalia Popovich. Yeah, you're welcome. Thank you.
And now?
Yeah, it's okay. Now it's okay.
My headphones.
I see. Okay.
Okay. Not used to work with to share the screen and work with Zoom or with Moodle. Awkward the first time. So. Can you see the screen well? Is it everything all right?
Everything is all right. Yeah, we can see it.
First of all, so my name is Natalia Popovich. I represent our research team. I'm associate professor at Uzhhorod National University. And first of all, I'd like to express our gratitude on behalf of our research team to members of conference organization to having given us the possibility to present our paper, because it's on its initial stage. It needs more research and work done. So Ukrainian redaction of Choice Slavonic needs for digitalization and text corporate platform generation. The investigation is in its initial stage and needs broader and deeper analysis, as I've already said, as well as high-level multidisciplinary experts. This paper provides several experiments. We used to name this long name, we just abbreviate it and say URCS. So to be clear, the paper provides several experiments and URCS digitalization main issues, as well as first results of the URCS text corpora platform. The research focuses on some threats. So, for example, the threat of extinction facing the URCS language. Also, constant planned substitution of it by the Russian redaction of Church Slavonic. It started approximately at the 19th century. We know the history well. Then the lack of evidence and research on the presence of the URCS language within English scientific literature, reviews, articles on this subject matter. And that's why it's very important to digitalize this language, which faces practical extinction, because it is practiced only in two regions, in two oblasts of Ukraine, Zakarpatska Oblast, very actively as a liturgical language, and in Lviv Oblast, and somewhere in Bukovina. That's all. So, historical overview research materials is based on famous Vasyl Nemchuk, Khairova, Anna Kuzemska, who has published approximately 10 years ago very good book on this Ukrainian redaction of Church Slavonic, and was presented and reviewed by Vasyl Nemchuk. And then we also included the work of Michael Moser and our own investigation. Here you can see a short historical overview. So we all know that first Old Church Slavonic texts were translated by Cyril and Methodius from ancient Greek, and it was based on the language spoken by Slavonic population of Thessaloniki. Then we had the period of Great Moravian period, Pannonia, Croatia, and Bulgarian state. Spread throughout the Rus, and so the fact is that all those versions of the Church Slavonic language were formed by the influence of local languages. And in such a way, also the Ukrainian redaction of Church Slavonic was formed under the influence of a real spoken language of the population, where it was spread and used as a liturgical language. So it was the mid of 13th century. The Old Slavic languages transformed more or less into a variety of redactions, or variety redaction, or izvod, say also a typical word for it. Now it is used, the Ukrainian redaction of Church Slavonic, it is used by the Ukrainian Greek Catholic Church, together alongside with the Ukrainian, modern Ukrainian, mostly Zakarpatska Oblast and Lviv. Also, Orthodox Church in Ukraine use Ukrainian. It doesn't use Church Slavonic because it was suppressed and substituted by Russian redaction, and they don't use it. I participated in several other conferences, so I have some proofs. And yeah, this is the fact of I am from Zakarpattia, I live in Uzhhorod, and I have many proofs that Ukrainian production of Church Slavonic has been substituted by the Russian production throughout 10 years. So it started approximately 10 years ago. These all facts tell us that there is a need to digitalize and to save this redaction of Church Slavonic for generations to come, so that the people have at least they are acquainted somehow with this language. It's our history. It's our Ukrainian history and the history of the Ukrainian language. So we conducted a small experiment to explore the use of URCs to show the connection with Ukrainian literature on the basis of MOVA Info. And we use as a first experiment, probably we will use later bigger dictionaries, but for the first step, we used Bilenka's Swistovich dictionary of 3,500 words and approximately 80 of 100 randomly selected words. We could find them in MOVA Info, so like this. So separately, we have many papers and tables with meanings of such words, and interesting that some of them preserved their meanings till nowadays, but some of them preserve their meanings in our Transcarpathian dialect. That is also very interesting. So from sketch engines, it was the easiest way to test one of our book in Ukrainian redaction of Church Slavonic. Okay, I will go backward. So sketch engine gives a possibility, as you see in the screen, for corpus to generate keywords, word list, engram, concordance, text type analysis. So developing the URCS corpus platform. Firstly, the URCS platform must be user-friendly. Secondly, the platform should offer a diverse collection of URCS texts. The problem is that all those collections that we can have at our disposal, they cover a wide time span, and that's why it will be somehow difficult to work with them. But later I will explain how we will solve this problem. Secondly, certainly the platform should allow for easy downloading and exploring of text of various formats, and sketch engine accepts OCR, PDF or TXT formats. And finally, the platform should provide support and resources for users who are not familiar, maybe not familiar with the URC language. This is our search query experiments on sketch engine. We have here in Uzhhorod one book experiment, Promin Dushi. It was edited on the basis of, I will show, Izbornik. So this Izbornik is written in real Church Slavonic, but it was transliterated for those churchgoers to make them easy to read Church Slavonic texts. So Promin Dushi, it is written in Ukrainian ABC alphabet, but the difference is that it has accents, so stresses. on every word, how to pronounce the word. So this version of Church Slavonic text, it is a huge book, more than 800 pages. We downloaded it into Sketch Engine and tried to create own corpus to have just an overview and to see all mistakes, possible mistakes that can be created by, that can be caused by search query, because we are aware of the fact that we need firstly, so the text should be elaborated, should be tagged and post-tagged and lemmatized, and all the process should be done. So the only search which was good, it was n-grams. So as you can see, the others were with mistakes. For example, the tagging. So to see lemmas, the forms, so initial dictionary forms of the word, they are all wrong because it is another language. So the program didn't recognize the words. So this is our challenge for our future research and probably paper. So challenge of the URCS platform development, given the diverse origin, yeah, I was said, and consistent use of diacritical marks, because from text to text, it differs, poses a significant challenge for the development. Possible solutions. Here on the screen, you have our ideas of possible solutions, but yesterday we had a meeting with our developers and we decided so to create our own platform. Probably we'll find digitalized libraries, but it needs time because there is no much information on it to find. So I will
make it shorter.
Our prototype, and that's all. So these are the first results. The project contains an authentication flow that is designed to allow users to secure a login. So this is actually how this platform looks like. So you can register and you can create your own corpus. So it is test version, obviously. The interaction processes and technologies overviews. So you can read about it in our paper because of lack of time now. But actually, it is possible to have text in 2 versions after you have downloaded it. So, so this is the idea, to preserve the PDF, so the picture of real Church Slavonic, and have it transformed into a transliterated version, Ukrainian text. It will be easier for researchers to analyze or to do research. So conclusions. The article highlights the significance of preserving the Ukrainian redaction of Church Slavonic, provides a brief Ukrainian corpora corpus to overview, and identify several issues that need to be addressed in the future. So the first task we will address, it will be user search query. How make it possible for user to search in at least one corpus that we will create. Thank you very much for your attention.
Question, how did you come up with such an idea of the choice of language, I mean?
It was probably the idea more of mine, or I don't know, because Actually, I am in a team project of our university, and we talked about heritage, our Ukrainian heritage, and I'm familiar with, so I have my second master degree in theology, so I'm expert also in such awkward modern society, awkward things. So church fathers literature, and I can read Church Slavonic from my childhood. I was taught by my grandma. That's why it's not, it's very close topic for me. And really, I see the necessity that the future generation should know the history, not only from the books, but can touch the history. And we have marvelous possibilities now in IT era to make these dreams come true, so to say.
Yeah, thank you very much. I see. So it's more of like your personal scientific area interest. Yeah, very nice. Okay.
But I have support of my colleagues and
yeah, of course.
Yes, and we are all very passionate, and just now, although there is much work to do on this topic, because in English-speaking world, I mean scientific Slavonic languages world, we digged a lot, but we didn't find a really decent research that will correspond. So there is a lack of knowledge in this area. So we can do it, and probably looking for financing of this project, because there is really much work to do.
Okay, thank you. And Olena Mykolaievna has a question, yeah, or it has already been like mentioned, yeah?
Yes.
Okay.
I have no.
Thank you very much for your presentation. Really great. New look, yeah, at new material. Okay, and we are passing to the next presenter. Have we got Andriy Vasylyuk?
Yes, I'm here. Yes, I'm here.
And you are the presenter, yeah?
Yes, I am the presenter. Okay, may I start? So, can you see my screen?
Yeah, we can.
Yeah, I'm associate professor of Lviv Polytechnic National University, Andriy Vasylyuk. Good day, dear colleagues. I would like to present you an article on the topic peculiarities of an information system development for studying Ukrainian language and carrying out an emotional and content analysis. Learning any language is relevant in the context of business, literature, culture, or politics. As for the Ukrainian language, the problem of learning it today is widespread, both among foreign citizens traveling for business and among residents of our country who, due to objective circumstances, want to improve their language skills. As you know, the most popular way to master Ukrainian language is to attend language courses or classes with tutors. However, these methods are financially and time-consuming and require changing schedules, which is not always convenient. Because of that, given the popularity of information technologies, the decision to make language learning accessible to anyone using software applications is promising. Another aspect of the research is the automated analysis of emotions expressed in the form of internet comments about goods and relevance, since more and more goods and services in the Ukrainian segment of the global network. Yeah, the mentioned problem is relevant since more and more Ukrainian language sources are being created on the territory of Ukraine, which do not include means of automated analysis for the analysis of reviews. After analyzing the literal sources, we can conclude that there are many ways for learning a language, and everyone can choose the most convenient one, but there are main approaches. Structuralist represents the language as a system of structurally interconnected elements with some hidden meanings. Functional, so this is presupposes language as a mechanism for performing various functions. For example, expressing one's opinion or requesting a certain service. And interactive, considers language as a means for creating and meaningful social connections, focusing around negotiations, activities, everyday communications, and others. The given list of methods used in learning foreign languages is not exhaustive, but the conducted analysis shows that an ideal method does not exist and is unlikely to exist, because each person is an individual, is characterized by different skills that should be taken into account in the learning process. Therefore, it can be concluded that the specified mechanism can be provided through an adaptive approach, which is planned to be implemented in the constructed system. Emotional content analysis is one of the areas of natural language processing, the purpose of which is to distinguish the thoughts and moods of people from written text. Sentiment analysis is extremely important in many fields, from business to politics. Today, it's widely used both for processing reviews about brands and for monitoring opinions in social networks about upcoming elections, attitudes towards certain events, or following certain processes or activities. The main areas of application of sentiment analysis are monitoring of social networks, monitoring of brand position, determination of the voice of the customer, and customer service. The main problem in learning any language is the many systems of analogs, which in most cases do not have the characteristics of complexity. Since the given tasks consist of two subtasks, the analysis of the existing solutions will be carried out in two directions. First is systems that specialize in learning the Ukrainian language, and the second is the systems that are used for emotional and content analysis. The main systems and their descriptions are shown in the slide. The conducted analysis showed that the available software is characterized by significant shortcomings, which makes the task of creating an information system for studying the Ukrainian language with possibility of emotional and meaningful content analysis an urgent task. The purpose of the research is the development of an information system for learning the Ukrainian language and the implementation of the emotional content analysis. The conducted research will provide means for creating on its basis software for managing informational and educational content, generating an individual learning environment for each user, and providing functions for emotional and meaningful analysis for user feedback. The results of the study solve the actual scientific and practical task for activating the meaningful and the motivational side of the educational process, and will provide the means to open additional opportunities for individualization and differentiation of Ukrainian language learning and monitoring of emotional content analysis. In order to present the main aspects of the studied subject area is its conceptual schema was built, which is shown in figure 1. As can be seen from the figure, the key tasks in the creation process are the construction of a database model, the development of methodological and algorithmic foundations of the subsystem for the construction of an individual learning and communication environment, the informalization of the learning and management process, and the provision of mechanism for emotional and meaningful content analysis. Further work was aimed at conducting a systematic analysis of the subject area using the methodology of functional modeling and graphic description of processes. For those purposes, a structural approach and the IDF0 standard, which is intended for the formalization and description of business processes, were used. A context diagram reflecting the process of forming an individual learning environment for learning in the Ukrainian language is presented in slide. That decomposition process was created taking into account the demarcation of knowledge management process, the organization of individualized training, and the implementation of emotional and meaningful analysis. As a result, the function model presented on slide was obtained. To implement the system based on the presented functional model, it's proposed to use a set of models and methods as a basis of software tools for managing educational content. This complex of models contains such components as complex content model, a model of educational content organization, a model of knowledge control and diagnostics, a model of educational inquiry, a model of the subsystem generating an individual learning environment, and the model of conducting emotional content analysis. Thanks to this, the functioning of the learning environment is ensured according to the concept in which knowledge management plays the role of preparing a repository of or knowledge portal, and the organization of learning is based on the methods of using this repository as a generator of an individual learning environment. The organization of individual training is based on the use of formalized knowledge, which is obtained at the first level of working with the system to build an individual learning environment. The organization of emotional content analysis will be based on natural language processing and will be implemented by a separate model that will provide tokenization and semantic analysis, lemmatization, stemming, part of speech tagging, identification of semantic relationships. After further decomposition of the presented model, we will present a detailed functional model of the system. As we can see it on this figure 1. The emotional content analysis level use a set of created rules to determine the main context. These rules will include the use of emotional dictionaries, which define a list of words with positive or negative connotations. The operation of the subsystem will include the following stages: identifying a list of polarized words, negative words such as bad, terrible, and other, and positive words such as good, kind, and assigning numerical values to them. Next is adding rules that have the greatest impact on the meaning of the sentence, such as use of not and other negative constructions. Next is splitting the input text into tokens and counting the number of positive and negative words in the source text, and conducting statistics on user sentiments. The process of implementing emotional content analysis can be divided into several stages: selection of algorithm for the system, selection, creation of dictionary of sentiments, creation of rules, collection, cleaning, and storage of data, emotional content analysis, output, and visualization of result. The display of the structure of the rules is given in the form of binary tree of decisions. After cleaning the data, an emotional and content analysis is carried out, for which is a set of rules and a corresponding decision. three are used. The result of the specific operations will be the formation of a Python dictionary, the key of which is feedback, and the value is emotional and content value expressed as a numeric value from -1 to 1, yeah, from -1 to 1. The next stage was development of the system using modern software tools. The development system is characterized by the intuitive interface and described functionality. When entering the system from the mobile application, the user is offered to choose the functionality that needs to be obtained, like learning the Ukrainian language or emotional content analysis. If you choose to study the Ukrainian language, the main window with the available main menu is displayed. A feature of the system is presence of various types of interactive tasks with the help of which you can comprehensively improve skills in mastering the Ukrainian language. The main categories in the form of a list of cards in the applications are categories of words, learn words, and pronunciation of words. You can see this on this slide too. As for emotional content analysis, when working with the system, it's necessary to enter the URL address of the corresponding resource containing reviews of the product, service, or brand, and check the possibility of accessing it. If everything is fine, the system downloads, cleans them, and analyzes them according to the described work algorithm. The result of the work can be presented in the form of a pie chart, a histogram, and a line graph. Yeah. As an example, we will present the results of the emotional content analysis of 50 reviews of product X from resource Y, yes, during 2 periods, September, June. And as a conclusions, as the analysis showed today, there are many software systems, but all of them are characterized by certain shortcomings, from the commerciality of the application to limited functionality, which makes the task of developing information system for learning the Ukrainian language and meaningful content analysis urgent. Models of structuring and formalization of knowledge and information presented in the context of the educational environment have been developed, providing the basis for the development and software implementation of methods of individualized user access to the requested educational materials. The next stage was the design of the software system using a structured approach. The study presents a functional model and is the composition which created the basis for understanding the peculiarities of the functioning of the Ukrainian language learning system and the implementation of the emotional and meaningful analysis. An applied software system has been developed, which provides methodological and algorithmic foundations for building an individual learning and communication environment, provides informatization of the learning management process, and conduct meaningful content analysis. Yeah, thank you for your attention. That's all. May you have some questions?
So have you already worked out the application? Yeah, so it can be used?
Yes, it can be used, but you can see that it's only 50 words was analyzed, and it's like, I think it's like a good start, but we have some issues. Maybe we can research in future and develop it better.
Okay, we wish you good luck. Okay, Salomia has a question. Salomia, you're welcome.
Okay, how many textual fragments did you analyze to reveal this negative and positive effects?
Actually, I can say this. I don't.
Just approximately.
Maybe you mean how length of all text fragment, or just
only for these emotions, negative and positive? Did you allocate them separately or the whole text you analyzed?
We analyzed not very long text because actually a review of some projects not always long. Yes, it may contain some 1, 2, or 3 tensions, and I don't know, maybe actually I can say how long. Yes, we must analyze. These reviews can be.
Okay. Okay, thank you.
Any other questions? Colleagues, you're welcome. No questions, it seems. Thank you very much. We wish you good luck in your further research. Okay, Yevhen Valerievich, how should we manage that? As actually we're going to have a coffee break, yeah, or your microphone? Because we don't have the presenter that we skipped.
All right. It seems that he will join the last part of this workshop, and
I see.
I would like to propose a coffee break as it was planned, so as to fit the next part of the workshop.
So when do we start?
We start as it scheduled at 11:30.
Okay, so now we are having a break. Thanks, everybody.
So it isn't necessary to disconnect. You can stay, everyone can stay here and wait till the beginning of the next part of the workshop.
Yeah, thank you.
And thank you to everyone who presented their reports.
So we continue our work, and the next presenter is Yevhen Fedorov or Olga, but I don't see them for a while. Nechiporenko, Olga Nechiporenko. What shall we do?
Let us. So we really don't have.
Yeah, for a while we don't have them. Probably they will join a little bit later.
Let us wait a bit.
Okay.
Our participants are connecting now.
Okay. Yeah, there are some more people joining, but still not the speakers.
Well, so Alina, will you announce once again the first?
Yeah, the speakers should be Yevhen Fedorov and Olga Nechiporenko. But are there? We have Olga Taloha, maybe that is the other person.
Let us wait a bit.
Okay, but we have the next speaker, yeah, Natalia Romanishin is here. So we still wait for Olga, yeah, and Yevhen.
And if in a minute we don't have our first reporters, we will have to skip this report till the end.
Okay. Yeah, there are really many participants, but not the speakers.
The first report to be presented is Linguistic Constructions Translation Method based on Neural Networks by Yevhen Fedorov and Olga Nechiporenko. So, dear guests or participants, is anyone who will present the report instead of these reporters? Is there anyone? Alina, I think we can skip this report and move on to the second one.
Okay, so the next is Natalia Romanishin. You're welcome.
Yes, thank you very much. So I'm here. Let me start and share my screen.
Yeah.
Okay. So,
Yeah,
can you see my presentation? So, let dear guests, the participants, let me now transfer you into the context of poetry, the context of romantic poetry, and present the findings of my research, corpus-based analysis of poetic actualization of emotions in English Romanticism. The variety of approaches from the perspectives of which emotions are treated inform the topicality of the research of linguistic and literary verbalization of emotions and feelings in the context of different epochs and artistic movements. At an empirical basis, I choose the text of 4 English Romantic poets, William Wordsworth, Samuel Taylor Coleridge, the so-called forefathers of English Romanticism, and Percy Bysshe Shelley and John Keats, so the younger fellows. All of them had a significant influence on the development of English literature and culture. Well, linguistic manifestation of emotions is versatile and covers the language elements of all language levels, from phonological to syntactic. Emotions are expressed figuratively or implicitly by language elements that acquire emotional or expressive meaning in the context. However, most researchers of language manifestations of emotions focus on the lexicon, the descriptive emotion words that, being subjected to corpus-based analysis, provide the researcher with the data that allow generalizing about the way of literary or poetic conceptualization of emotions and the author's idiostylistic preferences. In my study, I focus on lexical units that denote emotions, so the nouns as nominators of emotional concepts in poetic texts. The methodology of corpus-based approach realized in this research presupposes the following tasks and procedures. So the analysis of the frequency, combinability, and distribution of emotion words that denote or depict emotions with the purpose of defining their stylistic and pragmatic functions and their participation in actualizing the dominating metaphoric ways of conceptualizing emotion. So the first object of analysis is the poetic discourse of William Wordsworth. By applying tropes program, I identified the configuration of the field feelings and emotions in the poetry of Wordsworth. It was established the density of emotion nouns in poetic context, so they constitute 693 units, and the variability of lexical representations of the referential field, 51 nouns. We can observe a practically even distribution of emotions and feelings that belong to negative, positive, and neutral spectrum, and the examples you can see on the slide. The established models of to establish the models of metaphorization, I selected 10 emotion nouns with different frequency, and with the help of concordance program analyzed the contextual realization of their meaning and combinability. So the examples of nouns and their frequency you can see on this slide. The identified metaphoric models are the following. Feeling and emotion is an agent, creature, parent, thing contained, container, power, gift, precious, thing, or liquid. Emotion and feelings can act the course of physical or spiritual transformation, experiencing positive or negative states or sensations. So love can be transformed into pain or bliss, sorrow into pain, joy into sweetness or bliss, and so forth and so on. However, there is no possibility to speak about direct correlation between frequency of emotion concept and the frequency of their metaphorization. Emotion nouns are frequently used also in fixed episodes, being described some characteristics of modality of expressiveness and intensity. So similar procedures and algorithms of analysis have been applied to poetic discourse of other poets. So Samuel Taylor Coleridge. So it was established again that the density of emotion nouns in his poetic context is 1,790 units, and the variability of emotion noun that constitutes the referential field is about 100 nouns. The results of Coleridge poetic discourse analysis reveals the great coincidence in the spectrum of emotional concepts between Coleridge and Wordsworth. The list of common and specific nouns are also presented on the slide. However, the perceptible higher degree of emotional density and variability of poetic contexts in Coleridge discourse can be explained by the richer synonymic variations of basic emotional conceptual fields and the presence of nominations of emotions of high intensity and expressivity. For example, rapture, exaltation, beatitude, worship, entrancement, repentance, and etc. We can also observe the particularly even distribution of emotions of different spectrum. Well, they are presented on the slide. And again, to establish the models of metaphorization, I analyzed 10 emotion nouns that are common for poetic discourses of both authors and 5 emotional nouns that are specific for Coleridge discourse with different frequency. The identified metaphoric models are presented on the slide. So emotion of feeling is spirit, agent, mysterious creature, natural phenomenon, physical phenomenon, substance, flower, plant, disease, pain, doom, fate, power, container, or the thing contained. Duality, complexity, and ambivalence of emotional concept is displayed by their possible transformation. So for example, again, joy into sorrow, hope into despair, and vice versa. It also has been observed the tendency of frequent associations of positive emotions with voice, music, light, and negative emotions with load, flame, scream, torture, suffering that constitute the semantic grounds of episodes, similes, and metaphors. The performed analysis displayed only a general surface configuration of the space of poetic conceptualization of emotions and feeling in poetries of the first older generation of English Romantic poets. However, it can substantiate the ideas about the general features of poetic discourse of either author and to arrive at conclusions based on the comparative analysis. Thus, while both Wordsworth and Coleridge have much in common and share a focus on individual experience and exploration of human existence, their poetic system differed in terms of stylistic and conceptual dominance. These complex differences in poetic system of both authors is especially reflected in the ways of poetic conceptualization of emotions, difference in the volume of emotional lexicon, as well as in the richness of metaphoric models of emotion concept actualization. Poetic discourse of Percy Bysshe Shelley. The density of emotional concepts in Shelley's poetry is the highest. It's more than 5,000 units. However, the variability of emotional nouns does not exceed the number of 84 items. Most emotion nouns coincide with Coleridge ones. However, we also observe the direct correlation between the frequency of emotional noun and degree of its metaphorization. So the more frequent is the noun, the greater is the number of metaphors or other imagery units created by them. So again, the frequency of emotion nouns are presented on the slide. The defined metaphoric models include spirit, agent, mysterious creature, natural phenomenon, physical phenomenon, substance, again, flower, plant, doom, fate, power, container, or the thing contained, infinity, eternity, and depths, most of which are also characteristic for Coleridge poetry. And the richness of Shelley's emotional representation of reality is sustained by oxymorons, which was not characteristic for previous authors. Then poetic discourse of John Keats. The emotional density of Keats' poetic discourse is about 1,500 units. The variability of emotional concepts, however, is rather low, and its general palette is in coincidence again with emotional concepts of his fellow poets Coleridge and Shelley. Again, we can observe the practical coincidence in modeling of metaphoric concepts, except some additions. So the emotions and feelings are profiled or conceptualized through the notions of beauty, music, and voice. The richness of Keats' emotional representation of reality is sustained by the variety of synesthetic images. So, for example, such as sweet sorrow, melodious sorrow, and a number again of oxymoron constructions. So, sweet grief, the sweetness of pain, and etc. Keats' poetry is characterized by the complexity of emotional concept poetic presentations. Among them, there are sustained metaphors, complex metaphors, personifications, and complex episodes that embody the richness of author's imagination. So his desire to describe the emotion in all subtleties of its nature. Some examples are presented on the slide. Thus, both poets, representatives of the younger generation of English Romanticism, as we assumed, are characterized by different principles of poetic representation of emotions. By a rather limited number of poetic emotion nouns. For example, Keats manages to create emotional intensity of poetry due to the complexity of emotional images, extension of emotional nouns, contextual pragmatics, while the discourse of Shelley is the most prolific in the number of poetic contexts that contain emotional nouns as such, and by the realization of conventional metaphoric models characteristic for his older poets compatriots. And their density and contextual aggregation can create the vivid, perceptible, detailed, description of emotions. So this study focused on the lexical unit that represent emotions and their roles in creating romantic picture of the world in the poetry of English Romanticism. The study shows the importance of emotions and feelings in poetic discourse and their impact on the development of English Romanticism. It reveals the diversity of poetic systems of Romanticism through the prism of emotional concepts verbalization. As the application of the described computer tools is limited in their analytical potential for and application for poetic text and is not able to disclose the implicit ways of poetic conceptualization of the selected phenomena, emotions in the poetry can be studied through other analytical, can be further studied through other analytical methods such as close reading, comparative analysis, semantic analysis, contextual analysis, and the study of historical and cultural context of Romantic poetry can provide insights into prevailing emotions, attitudes, and beliefs of the period, and how they are reflected in the poetry. So thank you very much for your attention.
Yeah, Natalia.
Yeah.
Okay. Thank you very much for such a detailed investigation. And dear colleagues, have you got any questions? No questions. Such a detailed literary analysis. Yeah, I'm also fond of literature, so I really appreciate. Thank you very much.
Thank you.
It seems there are no questions. Okay, then we pass to the next speaker. It will be Yevhen Fedorov. And I give the word to my colleague Olena Yurchenko, so she will continue working with you. So Yevhen, please. We can see a demonstration, but we can't hear you for a while. Turn on your microphone. No, you haven't turned on the microphone.
Dear colleague, our work linguistic constructions translation method based on neural networks. Introduction. Currently, one of the important problems in the field of natural language processing is the insufficiency, high probability, adequacy, and speed of translation. This leads to the fact that the natural language interaction of computer agents in multi-agent systems may be ambitious. Thus, the criterion of models and methods that increase the efficiency of using natural language constructs for the interaction of computer agents in an agent task. Today, artificial intelligence methods are used to translate linguistic constructions, while the most popular is a connection approach, which for many networks allows them to have parallel learning methods. Recurrent networks for translate linguistic constructions. Elman neural network or simple recurrent network, bidirectional recurrent network, long short-term memory, bidirectional recurrent neural network, gated recurrent unit, bidirectional recurrent neural network. Purpose and objectives as a research. Purpose as the researchers is to develop a natural language construction translation methods. Objectives of the research. Analyze existing methods of translation, propose neural network models of translation, propose a criterion for evaluating the effectiveness of neural network translation models, create methods for determining the values of parameters of neural network translation models, perform a numerical study. Propose methodology. Modified neural network to secure for translation. Figure 1 shows propose a modified secure to secure neural network, which is a recurrent network. The modified secure to secure neural network includes an encoder and a decoder. Unlike the classical secure to secure neural network, there is no feedback from the output layer to the hidden layer in the decoder. Later, limit our consideration to the functioning of the N in the case when the encoder and decoder are based on N. It is assumed that a text input sequence of length has already been converted to an encoded input sequence, for example, by virtual and the length of each encoded word of the input sequence. It is assumed that an encoded output sequence of length will be converted to a text output sequence, and the length of each encoded word of the output sequence is equal. The number of hidden layers in the encoder and decoder is equal and 2 and 1 respectively. Functioning of the N. Integration, calculation of the output signal for the hidden layer of the encoder, checking the computation of encryption, a calculation of the output signal for the hidden and output layers of the decoder, checking the computation of the decryption. Modified additive attention neural network for translation. Figure 2 shows proposed modified additive attention neural network, which is a recurrent network. The modified additive attention neural network includes an encoder, an attention mechanism, and the decoder, unlike the classical additive attention neural network, there is no feedback from the output layer to the hidden layer in the decoder. The attention mechanism allows the decoder to focus attention on certain outputs as the encoder. Let us limit our consideration to the functioning of the N in the case when the encoder and decoder are based on. It is assumed that a text input sequence length has already been converted to an encoded input sequence, for example, word to vec, and the length of each encoded word as the input sequence. It is assumed that an encoded output sequence of length will be converted to a text output sequence, and the length of each encoded word as the output sequence. The number of hidden layers in the encoder and decoder is equal, and 1 and 2 respectively. Functioning as a initialization, calculation of the output signal from the hidden layer of the encoder. Checking the computation of encryption, additive attention, concurrentive additive attention is used, which connects the encoder's hidden layer as the decoder's hidden layer. Calculation of weights estimates of attention. Context calculation, calculation of the output signal for the hidden and output layers of the decoder, checking the computation of decryption. Modified multiplicative attention neural network for translation. Figure 3 shows propose a modified multiplicative attention neural network with a recurrent network. The modified multiplicative attention neural network includes an encoder, an attention mechanism, and a decoder. Unlike the classical multiplicative attention neural network, there is no feedback from the output layer to the hidden layer in the decoder. The attention mechanism allows the decoder to focus attention on certain outputs as an encoder. Let us limit our consideration to the function of the N in the case when the encoder and decoder are based on. It is assumed that the text input sequence of length has already been converted to an encoded input sequence, for example, my word to vec, and the length of each encoded word of the input sequence. This is assumed that an encoded output sequence of length will be converted to a text output sequence, and the length of each encoded word of the output sequence is equal. The number of hidden layers, the encoder and decoder is equal N1 and N2 respectively. Functioning as a initialization, a calculation of the output signal for the hidden layer as an encoder with the concatenation of all outputs. Checking the computation of encoding, calculation of the output signal for the hidden layer of the decoder, multiplicative attention. Multiplicative attention is used, which links the hidden layer of the encoder and the hidden layer of the decoder. Calculation of weights estimates of attention. If the multiplicative attention is general, then if the multiplicative attention is dot, and then context calculation, calculation of the output signal for the hidden and output layers of the decoder, checking the computation of description. An additive attention neural network with pointing. In this paper, proposed an additive attention neural network with an indication for translation, similar to figure 2, which is a recurrent network. This additive attention neural network with pointing includes an encoder, an attention mechanism, a pointing mechanism, and a decoder. Unlike a classical additive attention neural network, the decoder does not have feedback from the output layer to the hidden one, and the pointing mechanism is added. The attention mechanism allows the decoder to focus attention on specific encoder outputs. The pointing mechanism allows the decoder to focus on specific encoder inputs. Let us limit our consideration to the function of the N in the case when the encoder and decoder are based on. It is assumed that a text input sequence of length has already been converted to an encoded input sequence, for example, a word to vec, and the length of each encoded word as the input sequence. It is assumed that an encoded output sequence of the length will be converted to a text output sequence, and the length of each encoded word as the output sequence is equal to. The number of hidden layers is encoded and decoder is equal to N1 and N2 respectively. Functioning as an initialization, calculation of the output signal for the hidden layer of the encoder, checking the computation and encryption, additive attention, concurrentive additive attention is used, which connects the encoder's hidden layers and the decryptor's hidden layers. Calculation of weights estimates of attention, context calculation, pointing, calculation of the output signal for the hidden and output less of the decoder, checking the computation of the criteria for evaluating the effectiveness of neural network translation models. In this work, for the training of neural networks translation models, the criterion of model adequacy was chosen, which means the choice of such values of parameters that delivers maximum accuracy, the goal sentence of the model output and the desired output. Training of neural network translation models is subject to criterion 1. Message for determining the values of parameters of neural network translation models based on the Adam methods. Let the value vector be defined as let an energy array be defined as, let the vector of partial derivatives gradient be defined as initialization. The vector of the first moments is calculated based on the exponential moving average. The second moment vector is calculation based on the exponential moving average. The vector of weights is calculated, traditional variant, variant comes gradient is calculated. Experiments and results. The numerical study of the proposed method for determining the parameter values was carried out in the Google Collaborator environment using the TensorFlow page. To determine the structure of the secure modified neural network model, additive attention, multiplicative attention, additive attention with pointing 256 input neurons, determining the number of hidden neural. Several experiments were carried out, the results of which are presented in figure. The standard data set engine was used in the book data to determine the values of the parameters of the neural network translation model. The data are contained to some records. The criterion for choosing the structure of the neural network model was translation accuracy. For translation, it is the vision is a 256 hidden layers corresponding to the number of input neurons. Since with a further increase in the number of hidden neurons, the change in the accuracy value is insignificant. Similar studies were carried out on the standard datasets for ENG and eta-ENG, and similar results were obtained. Figure 4, as can be seen from figure 4, with an increase in the number of hidden neurons, the accuracy value increases. Table 1 presents a comparative description of neural networks for translation. Table 1 shows a modified additive attention with pointing to the highest translation accuracy. Conclusions. To solve the problem of improving the accuracy of the translation of linguistic structures, the existing methods of neural networks translation were investigated. These studies have shown that today the most effective is the use of recurrent neural networks. To improve the quality of the translation of linguistic structures, a mathematical model of modified secure-to-secure neural networks, additive attention, multiplicative attention, and additive attention with pointing were created. Unlike the corresponding traditional neural networks, in the decoder of proposed modified neural networks, there are no feedbacks from the output layer to the hidden one. The decoder structure, that is with the encoder structure, we simplify the practical implementation of the decoder. In the course of a numerical study of a neural network translation model, the structure was determined. The experiments performed showed that with 256 hidden neurons corresponding to the number of neurons for encoding one word, the accuracy value does not change significantly, and the selected network gives translation results with a maximum accuracy. The proposed approach can be used in various intelligent systems as they use the translation of linguistic structure, for example, in computer systems for supply chain management or natural language interaction between subjects, which are represented by computer agents, plays an important role. Thank you for attention.
Thank you for such meaningful report. Has anybody got a question? No questions? Okay, thank you. We pass to another speaker. Yes? The another speaker will be Irina Khomitska.
Irina Khomitska.
Irina, I'm sorry.
Good afternoon, dear colleagues, dear researchers. I'm from Applied Linguistics Department, yes, and my from Lviv Polytechnic National University. My co-authors are Vasil Tesluk and Irina Karamasheva from the same university, and Irina Bazilevich from Ivan Franko National University. And the title of my report is Automated Identification of Authorial Style. And I'll just try to put on my presentation. Yes. Yes. Presentation. Yes. Well, okay. Outlines of the research. The demand for author identification increases with the increased number of texts in all spheres of human activity in the internet. The author identification should be done for various reasons. These are scientific and educational settings, judiciary, and the approaches to the author identification differ, yes, but there are the main three aspects in which the approaches are different. The first one is the methods applied. They may be the machine learning methods and the classical methods, or both combined. The second aspect is that of the language level on which the research is done. That may be phonological, lexical, and syntactic. And the third one is the linguistic material. The test validity of the author identification depends on the three aspects mentioned. Topicality. There is a lot of research on the topic, on this problem of the author identification, but there is still a need to enhance the test validity of the author identification. It may be done by finding the most efficient approaches, most efficient methods, maybe machine learning methods or classical methods, or both combined, applied on the appropriate language level and on the appropriate linguistic material. And the basic problem here is the most complex one, is that of separation the authorial style features from the other features, such as topic features or style features. Analysis of publications. As the analysis of publications in recent years has shown, yes, in most cases, the problem of the author identification is researched with the help of machine learning methods, and in most cases on the lexical and syntactic language levels. And the test validity for the machine learning methods is 70–90%. In our research, we combine the machine learning method, the discriminant analysis, with the classical method, the chi-square test. Because the classical methods ensure more reliable data, they ensure a higher level of test validity. In our research, it is 95, as we have chosen the significance level 5%. The purpose of our research is to prove that the chosen combination of the machine learning method, the discriminant analysis, And the classical method, the chi-square test, is the most efficient for the author identification. The novelty of the research is the proposed structure of the program system based on the modular principle and the use of the combination of the mentioned methods applied on the material of the Ukrainian emotive prose. Yes, actually on the material of literary texts by Yevhen Franko, Les Honchar, and Leonid Glibov. And as far as the algorithm of the applied method is concerned, so there are the following steps: calculation of absolute, relative, and mean frequencies of occurrence of the researched linguistic units in our research, that is, function words, letters, spacers, and punctuation marks, and the use of chi-square test. And for the discriminant analysis, we use the formula of Mahalanobis distance. On the slide, we see the formula of the chi-square test, and if the homogeneity hypothesis is not rejected, this means that the literary works belong to one author. That is a very good result, yes. And as for the computer program realization, the algorithm consists of the following steps: files, uploading, sample formation, sample division, calculation of frequencies of occurrence, and application of the chi-square test and the discriminant analysis. Yes, as the results obtained show, yes, the chi-square test ensures very good results because the homogeneity hypothesis is not rejected, and this means that the research literary works belong to one author. So this test can be used quite successfully for the author identification. And as far as the discriminant analysis is concerned, Mahalanobis distances, yes, squared Mahalanobis distances also show very good results. We see that the distances between the literary works by one author are much smaller than those between the literary works by different authors. So the discriminant analysis is also a very good method for the author identification. And conclusions. So in our research, we have proved that the proposed combination of the classical method, the chi-square test, and the machine learning method, the discriminant analysis, is efficient. The test validity is 95%. The research has been done on the material of the Ukrainian emotive prose, yes, and on the language level of letters, function words, spaces, and punctuation marks. Yes, and the results have their practical application. They can be applied for anonymous text identification and documents identification, as well as for differentiation of scientific papers and literary works. In our future research, we plan to test another combination of classical and machine learning methods on the other language level and on the other linguistic material. The presentation is over. Thank you for your attention.
Thank you, Pani Irina, for that very interesting report. Has anybody got questions? Okay, if nobody has a question, we pass to another speaker. Yeah. The another speaker will be Petro Zdebski.
Petro Zdebski.
Zdebski. Hello.
Yes, let me share my screen. I had to reopen Zoom because to share my screen, I need to apply the settings. So to allow my computer to share the screen, because for some reason there are some security problems, and I'm just trying to. So let me reconnect to the Zoom again. Sorry.
Yes. Okay.
Can you see my screen right now?
Yes, we see.
Okay. Let me start. Yeah, so the name of my work is Investigation of Transitivity Relation in the Natural Language Inference. My name is Petro Zdebski. I'm from Lviv Polytechnic University, and my co-authors is Andriy Berko and Victoria Vysotska, also from Lviv Polytechnic National University. So the motivation of this work is, sorry, let me. Some reason I cannot. Okay, so the motivation of this work is a data-centric approach of improving model accuracy by improving data quality instead of improving model architecture. So the idea is to improve the data set with the transitivity relations to help machine learning model to learn such dependencies. And alongside with enriching the data set, investigate how good is previously pre-trained model in catching such transitivity relations. So what is the transitive relation? We can see on the left the formal definition and informal definition. Transitivity relation, it's if there any edge from one vertex to another, then there should be a pass from one vertex to the second one. For example, if there is a link from A to B and there is link from B to C, then there should be a pass from A to C. The good example of the transitive relation is the operator of comparing numbers. Like if A is greater than B and B greater than C, then A is greater than C by the definition, because this operator of comparing the numbers is by definition is a transitive operator. And what is a natural language inference task? Natural inference task is a good benchmark for natural language understanding research, where two sentences passed to the model and asked to determine the relationship between the selecting of one of three options: entailment, neutral, and contradiction. And success in NLI, or natural language inference, doesn't demand complex machine learning skills, but rather an ability to understand the meaning of the sentences lexical and compositional semantics, as well as phenomena such as quantification, tense, beliefs, modality, and lexical and syntactic ambiguity. The data set that was used, so the study solely relies on the multi-NLI data set, which is considered the largest data set for natural language inference and supports multiple languages. Multi-NLI consists of sentence pairs that are annotated with textual entailment information, and it covers different genres of texts. So on the left screenshot, we can see the sentences, the name of the genre, and the labels. So basically, first sentence is called premise, and the second one is called hypothesis. And the goal of this natural language inference is to actually guess the label, basically. If there is entailment from the first sentence to the second one, if there are contradictions between these two sentences, or they have like very different meaning and these are neutral. Model. The model that was used called Roberta. It's a huge deep learning model which is trained and fine-tuned on the previously mentioned data set by the Facebook. And this is improved BERT architecture, but performance was improved by training the model on the more data for longer period of time, removed the next sentence prediction objective, and dynamically changes the masking pattern on the training data. But I want to say again, it's not trained by me. It's basically the pre-trained model by the Facebook, and the task was to check the accuracy of this model on the transitivity relations on the data set that is created using these transitivity relations. If we have entailment in the first pair and there is entailment in the second one, then there should be entailment relation between the premise of the first pair and the hypothesis of the second pair. If we have two pairs from the original data set, for example, first pair is I have been to Paris, and the second sentence from the first pair is I have been to France. We can see that this is entailment because you cannot be in Paris without visiting the France. The label will be in the original data set, the entailment. And the second pair is I have been to France and I visited France. It's also basically the same meaning. So this is the entailment. And from that, because the second sentence of the first pair and the first sentence of the second pair are the same, and those are I have been to France, we can merge those sentences and make a transitive relation from the first sentence of the first pair to the second sentence of the second pair. So we can say that I have been to Paris and I visited France is entailment based on that rule. And those rules are described on the screenshot on the right for different classes, and those are made based on the domain knowledge. So here I can show the examples of the results. So on the left, there are the original data set. And on the right is the data set constructed from the original data set based on the rules that I showed on the previous slide for transitive relations. So we can, for example, look at the second line on the left data set. I'm afraid not, sir, and I don't think so. Those are entailment because it's just like a disagreement and showing their opinion, and the predicted label and the true label are basically the labels. First one, the predicted is predicted by the model, and the true label is labeled by the people who created this data set. And from the same line, we can see on gray, I don't think so, and I have no real idea. And the true label is the contradiction, but predicted label is neutral. So we can see that I don't think so means the disagreement, and I have no real idea means it's not a disagreement, but rather the like saying that that the person has no any opinion on the topic. So it's a pure contradiction, and the true label is a contradiction, as we see. But the model is misclassified this sample, and I highlighted all misclassified samples on the screenshot with a gray. So this is the original data set, and we can see that even on the original data set, model misclassify some of the samples, because model cannot be like 100% accurate, because it will just overfit. So but from that data set, I created my data set on the right, which is made by the rules of the transitive relation. Also, we can see the second line. I'm afraid not, sir, and I have no real idea. These are the sentence. These are the first sentence from the first pair and the second sentence from the second pair from the same line on the left data set. So I basically, for each line on the left data set, created the line in a new data set, but with the transitive relation between the first sentence in the first sentence pair and the second sentence on the second sentence pair. And then I checked the model on this right data set, on my constructed data set, and we can see it also has misclassified this sample because the labels are different, but we can see that it must misclassify this because it has even a problem with the same sample on the original data set. And what I found that the problems with the classification on my new constructed data set with transitive relation, and this misclassification was only on the sample that was misclassified in the original data set. So on this slide, we can see that on the constructed data set, model have inaccurate prediction only on the samples which were problematic for the model, even on the original data set. But for any other samples that are classified correctly on the original data set, the model classified them correctly, even with the constructed transitive relation. So we can say that Roberta model catch transitive relation pretty well. And every incorrect classification is not related to the nature of the transitivity relation that we are trying to understand, but to the inaccuracy of the model on the general natural language inference task. And also model entailment and from hypothesis to premises. It wasn't planned in the initial scope, but I decided to check if what we will get if we swap the first and the second sentence in the original data set. And on the table on the right, we can see that the accuracy decreased by the factor of 2.97, 1.17, 1.26 for class similar or entailment, neutral, and contradiction respectively. So the biggest drop in accuracy we can see for the class entailment, almost by the factor of 3. So from that we can infer that the class entailment is the most directional relation, and the most directional compared to the contradiction and the neutral. And this is pretty logical because, for example, if you've been to Paris and the second sentence, I was in France, but this doesn't mean that if we swap these two sentences, we can say this is entailment, right? But if we swap these two sentences, we can say if I was in France, this not necessarily mean I was in Paris. So it not always will be entailment if we swap these two sentences. But I did that only to check how directional these three labels are. And from that, and based on our natural understanding of the domain, and also by the results of the classification, we can say that entailment is the most directional, and we can say that the nature of entailment is the most directional compared to neutral and the contradiction. Thank you.
Thank you. Thank you, Pan Petro. It was very, very interesting. Have anybody the question? If there are no questions, the next report ou Kupriianov Yevhen, est-ce que nous pouvons, do we pass to next report or the break?
So we can have a break as it was planned by the program, as it scheduled. Till
Okay.
13:15.
Okay, it's a break till 13:15.
Yes. It's time. Well, hello, everyone. Hello once again. We continue our workshop on computational linguistics. Now I will present the report, application of neural networks to identify fake news by Irina Afanasyeva, Natalia Golian, Vera Golian, Artem Hovrat, and Konstantin Onishenko. Well, you're welcome.
Hello. Should I? Yeah. One moment, please. Yeah. Hello.
Hello.
Yeah. Can I use a record of my presentation, or I should?
Yes. The video session is recorded. It's been recorded.
Okay. One moment, please. Yeah. Hello, dear audience, and today I wanna introduce the result of our investigation about application of neural networks to identification of fake news. And as of today, given the general political destabilization in the world, the number of fakes has increased both in absolute and relative terms. Some of them can be attributed to the incorrect subjective perception of real information, but a significant number is the result of military propaganda. Before the beginning of the full-scale invasion of the Russian Federation on the territory of Ukraine, a vivid example of manipulation with fakes was the information about the spread of coronavirus. In particular, the story about Eden beds and the global conspiracy about vaccine. The global trend towards combating such information is generally positive, but the problem lies in determining whether the information is fake or not. If the decision is based not on facts, but on expert assessment, then such situation can be considered manipulative. For countries, for governments, the process of identifying fake news can be automated using artificial intelligence. Initially, naive Bayes or SVM were used as a basic method, and we can read a lot of information about these approaches. But with the development of neural networks, especially convolutional and recurrent neural networks and LSTM architecture, gains the most popularity. It's worth noting that given numerous studies, these models can give different results depending on the subject area. Therefore, it was decided to consider the effectiveness of using these models to identify fake news to optimize their selection during the development of an appropriate software system. And the main purpose it's to choose a good approach, a best approach for use it to determine which news is fake or which information is fake for big anti-fake system. On the slide, you can see the brief information about this subject. this work, and the object of research is convolutional and recurrent networks, neural networks, and the Python language, and especially the Keras and NLTK libraries, are considered as solution methods. First of all, the tasks of identifying fake news concern the process of processing natural languages. So for now, we will focus on how it's possible to detect whether this or that news is fake. You can see on the slide dictionary with words about with words from use about 2016 presidential election in the United States. It contains more than 20,000 news, of which 12,000 are fake and 8,000 are real. And the real news in this set is data from well-known authoritative news websites, such as New York Times and Washington Post. And yeah, we can say that these sources also can generate some fake news or some false information, but in general cases, their news is good, is real. The first thing to note is that at the same time, we will consider this data set from the perspective of the next approaches: computational linguistics, psychological positioning, lexical diversity, and sentiment analysis. The first thing to note is that fake news has fewer words on average than real news. In addition, the range of words in fake news is much larger than in real data. Despite fewer characters and sentences, the sentences themselves are shorter in fake news. Other similar patterns are shown on the slide. You can see the number of verbs. The denial is almost never used in fake news. Also, which pronouns and marks or question and exclamation marks used less in fakes. Yeah. The mood in real and fake news is significantly different also. As can be seen from the figure on the slide, both the median value and standard deviation value indicates that fake news is more negative. Several reasons can be identified that would explain this phenomenon. First, the creation of false information is aimed at inciting the population. Accordingly, the mood of the text should have a negative color. Having reviewed the main lexical regularities, we can proceed to review of narrow network architecture. Let's start with convolutional ones. They consist of three types of layer: convolutional, subdiscretization, and perceptron. The first one is based on a set of filters that pass through the entire depth of the input volume of data. While passing through the network, the filters slid over the width and height of the input data, during which the scalar product between the filter entries and the input information is found. As a result, a two-dimensional activation map is formed, and the screen shows the hyperparameters, list of hyperparameters that need to be configured for this network. It's depth, stride, padding, bias, and kernel size. Having considered the architecture of convolutional networks, we can remove to the recurrent, but I should speak a lot about CNN architecture for text analysis. You can see that when applying CNN to process and analyze this textual information, the number of convolutional layers is 1, and all hyperparameters have certain practical limitation. I can say that I use a stride equal to 3 and bias equal to 1. Also for get my result, which you can see on the next slides. Okay, the figure on the slide depicts the recurrent boundary of each point in time, showing the presence of 3 layers: input, hidden, and output. And the learning process occurs by back expansion in time, when new weights are obtained as a result of the record of the current processing. The classical architecture of the recurrent network is not suitable for the full processing of textual information. Thus, it was decided to consider the LSTM architecture shown on the screen, and you can see that this architecture have long-term memory. It's this side, yeah, and it was chosen for the next investigation. Let's proceed to consider the processing algorithm. First, all non-literal expressions are removed from the text, then those words that do not carry an informational load, I can say load, or not useful information. The next step is to level the linguistic variability. For this, the stemming operation and lemmatization are used. After processing the text, the dictionary is created that is necessary for the correct definition of TF-IDF characteristics. To take into account the emotional coloring of words, the next step is to find a frequency polar characteristic for each word by multiplying the TF-IDF and polarity indicator. In this case, the polarity is defined as the degree of fakeness based on the previously analyzed data set. Having considered all the necessary structure elements, we will proceed to the experiment. You can familiarize yourself with the experiment plan on the screen. It's a function efficiency and comparison rule and experiment design. As the target data set, it was decided to use data about the election in the United States, right side, and the news from Telegram channels about the war in Ukraine. All news in this data set in Russian language and in this data set in English. And I should say that I use variable NLTK models for processing Russian and for processing English texts. The average result of the experiments are shown on the slide. As we can see from the presented data, the CNN model works faster than LSTM, but gives a less accurate classification result. Given the proposed efficiency comparison rule, the stated probabilities of errors of various kinds and ways to overcome the disparity between algorithms, the resulting efficiency gains be considered insignificant. Yes, as further goals for deepen the search, it's proposed to consider the possibility of combine a recurrent and convolutional network. As a conclusion, I would say about that as a result of research task, the field of fake news and the effectiveness of using artificial intelligence tool for their detection were analyzed, and the relative efficiency of using recurrent neural networks compared to convolutional neural networks is proven. And we can say that every these networks have pros and contras, but I use in my small software, I use the LSTM architecture for gain more precision results. Yeah, that's all. You can see references on the slide, and thank you for your attention.
Thank you for your interesting and topical report. Probably the guests and participants may have some questions to you. Well, does anyone have questions? Well, and I'd like to ask you the following. So, how to what is fake and what is real information in terms of neural network? How does it define? So, and this first question.
We can see can I change the slide? Sorry. We can see the fake information have more negative connotation. So if we find TF-IDF multiply polarity characteristic, we can say that in situation when the text is more negative connotation, this text should discuss especially because maybe it's a fake news. So the next we should find this, apply these rules. So we should count the amount of verbs, and we have standard, maybe I can say standard, yeah, no standard, no standard, optimal etalon, yeah, etalon data set, where fake news and real news are separated. And when we count the number of words, verbs, a number of pronouns, these texts have denial or doesn't have denial, didn't have denial, we can say, yeah, this negative connotation text is a fake. So we can mark it as fake. Yeah, we can say that sometimes we have false negative, cases, false negative cases, sorry, and it's the truth, but sometimes this news with negative connotation and verbs can be displayed in like a real news, but after some times we understand, oh no, it's a fake. So I think the linguistic analysis based on this data set, based on some researches which I described in my references, I can say that, okay, I can use this etalon for implement my own approach with pre-processing of text to identify its news is fake or its news is not fake. And when I receive when I apply some ifs, some ifs, I can say, yeah, it's a 0, no, it's 1 and it's fake. It's 0, it's not fake. And then I can teach a neural network on this information.
Thank you very much. It was very interesting, really. Thank you for your report once again. And now we move on to the next report titled Research of Medical Terms Substantives on Oksana Zabushko's artistic works on the basis of the text corpus by Lilia Kharchuk, Zoriana Kunch, and Miroslava Gnatyuk. You're welcome.
Thank you very much. I'll just try to share my screen. Can you see my screen right now?
No.
No, not yet.
Sorry. Yeah.
And right now?
It's been uploaded. Your presentation is being uploaded, but we still can't. Oh, yes, we can see it now.
Yeah. I want to introduce our investigation on the topic research of medical term substantives in Oksana Zabushko artistic works on the basis of the text corpus. My co-authors is Zoriana Kunch and Lilia Kharchuk. They are from Lviv Polytechnic. Statement of scientific problem based on the analysis of medical terminologies used in Oksana Zabushko's works, and selected by identification from the general regional annotated corpus of the Ukrainian language, GRC, www.vacorpus.org. It was found that the term vocabulary organically enters into an artistic journalistic context and becomes an important component of the writer's individual creative handwriting. The relevance of the research is due to the need of modern linguistics to define the role of the terminologisms, medical in particular, in artistic and journalistic discourse based on the work of modern writers. The novelty of the work is that for the first time, linguistic statistical analysis of the use of medical term substantives of the work of the modern Ukrainian writer Oksana Zabushko was carried out, which allowed to select all quotes from her works, which used the terminologisms classified into 3 groups according to the level of determinologization and identify the typical models aimed at achieving a stylistic effect with the use of medical determinologies. The goal of our work is to reveal the stylistic role of medical term substantives in the writer's work using a corpus of texts. The source base of the research was a card file created on the basis of a continuous selection from the online concordance of Oksana Zabushko's works, in which medical term substantives single out in the context of their use. Methods and materials. The contextual analysis, the use of which helped to distinguish from the context studied in SEMS, to find out their compatibility in micro-context, to identify emotional and evaluation connotations. The use of distribution modeling made it possible to highlight the functioning of the word and its compatibility. The collected material is classified and described using the structural descriptive method, taking into account the following consecutive stages: linguistic observation, analysis and fixation of language material in its functioning, inventory, the selection of the terminologisms in the works of Oksana Zabushko, taxonomy, the classification of lexical units by attributive compatibility and part language affiliation, interpretation, identification of features of taxonomy groups. The inductive method helped to summarize the results of specific observation and show the overall picture of use of medical term substantives in the work of Oksana Zabushko. Results and discussions. Text fragments from the works of Oksana Zabushko in which medical term substantives are used extractly from the general regional annotated corpus of the Ukrainian language area C15 are unequally represented in the writer's various works. The highest frequency of use of medical terminological determinisms is observed in the book Notre Dame de Ukraine, Ukrainian Woman in Conflict of Mythologies, and in the novel The Museum of Abandoned Secrets. This can be explained first of all, by the volume of both editions and their subject matter. Since a significant number of medical terms substantive are used in their term meaning, in the writer's small works, medical term substantive occur singly, but they are determinologized both at the lexical semantic and the semantic stylistic level. Separate medical term substantives also demonstrate unequal frequency in different works. For example, the determinism likar, doctor. Or the terminologisms diagnosis. The lexical semantic analysis of the selected material and its statistical processing gives reason to state a significant advantage of functional determinologisms. They are used in the term sense, but outside their terminological field. The lexical semantic determinologisms that lose partly their definiteness, moving from their terminological system to another semantic field. Such determinologisms modify, usually spread, their semantic, and often these common meanings are reflected in common language dictionaries. The semantic stylistic determinologisms loses its definitive signs. It becomes a new shade of meaning and also becomes an element of artistic means, trope, stylistic figure, etc. For most part, medical terminologisms demonstrate the ability to be actively used at all levels of determinologization. For example, such a dynamic is demonstrated by the term pulse, found in texts of writers' works. In addition to the immediate meaning of this word, we observe figurative and expressive contexts. Pulse mista, the pulse of the city, pulse progresso, the pulse of progress, pulse filosofской думки, the pulse of philosophical thought, pulse истории, the pulse of history, etc. Conclusion, the term vocabulary organically enters the artistic publicistic context. It becomes an important component of the writer's individual creative style, contributes to the achievement of a creative idea. The terminologisms in the work of Oksana Zabushko are designed to create new, bright, and original stylistic tools and to increase the emotional impact on the reader, to saturate the text with expression. Thank you for your attention.
Thank you. It was very interesting linguistic survey. And dear guests, you are welcome. Feel free to ask someone some questions. Especially, I welcome the students to ask questions because, as Tatiana Shostakevich said, that they may be interested in corpus assisted linguistic researches. So students are also welcome to ask questions. No?
I have the question. To Miroslava. So it's really very interesting research, but I'd like to know whether you focus only on one author, or you can maybe state or claim that the processes of determinology of the losing, when the terms lose their direct function and penetrate into other styles and sub-styles, is the tendency of, for example, Ukrainian literature, Ukrainian literary discourse, what other authors are prolific in for their research from this perspective. Well, maybe poetic texts, prose texts. So because, well, it's very interesting approach from lexical point of view, lexicosemantic point of view, well, but from stylistic and cognitive stylistic point of view, so such phenomena are treated as the change of function or the shift of function of terms. Well, they do not lose their meaning, well, but they acquire additional functions. So what is your attitude toward this statement and toward this phenomenon?
We research only text Oksana Zabushko, but in the future we hope to try another text. We have examples from another scientists which analyzed the artistic work, for example, Panas Myrny or Mykola Khvelyovy, Ukraine or Mala Russia, and another investigation. And I hope that it will not only ended of in Oksana Zabushko texts, and we will try to investigate
deeper research, different kinds of semantic stylistic and semantic stylistic the transformation, and investigate different terminology, different sectoral terminology in our artistic works in literature, in our literature, Ukrainian literature. Thanks.
Any more questions?
Okay, can I ask a question?
Yes, please.
Okay, in your opinion, what other sectoral terminology systems are promising as objects of research into Oksana Zabushko's works based on data from the corpus of texts? Because you mentioned that it will be possible.
I don't exactly understand what you asked me.
So, yeah, just you said that in the future. So in the future, you will have like more research. And what other sectoral terminology systems are promising as objects, right? So right now we have like medical, right?
Yeah, I understand. Yeah. When after the medical research, we perhaps try to investigate musical terminology, physical culture and sport, and mathematic and biological terminology, because there are many themes which are concerning in text works of Oksana Zabushko. Thanks.
Okay, thank you.
Any more questions? Thank you very much. And now I announce the next report entitled Corpus Analysis of Word Semantics by Alla Taram. Well, is Pani Alla present today? We will have to skip this report, unfortunately, and I give word to Tron the Kwan and to present two reports. Mr. Tron the Kwan, you are welcome.
Hello, everyone. I'm from Vietnam, and today I'm very pleased to introduce an attractive topic about speech enhancement. And the topic named Mask-based minimum variance distortionless response informing using the power level difference. And the introduction, as we know that nowadays targets extracting digital signal processing and read separated the desired talker in an annoying complex environment when third-party speaker interference and living equipment or background noise exist. And this method serves as an essential pre-processing front-end for several speech communication systems such as speech acquisition, speech enhancement, and surveillance device, smart home, and automatic speech recognition. And with the recent development of microphone array techniques, several research about microphone array beamforming, which is a priori spatial information about the direction of arrival of the useful signal, the property of surrounding recording environment. And MVDA beamformer is one of the most suitable techniques which installed in almost speech application for suppressing background noise with speech distortion. Microphone array is used in almost speech application, and the using of microphone array for extracting the receptor and beam pattern, the essential component microphone array beamforming. And in this slide, we know that the principle working of NVIDIA beamformer based on the constraint problem to minimize the power noise at the output of beamformer without speech distortion, and the optimum solution in equation 6, and the matrix of growth. However, in the optimal solution, we use the only information of noise. But however, in the realistic environment, we can it's difficult to determine the matrix cross spectrum of noise. We use the observed microphone arrays. Therefore, the matrix of cross spectrum of received arrays is used, and the coefficient of NVIDIA beamformer are given by the equation 9. And the outer proposed spectral mask to separate the speed component at the original microphone arrays, and MSP, for example, we suppress the speed component at the recorded microphone array, and the idea of suggested MSP based on the exponent function of the power level difference PLD as the following way. And the experiment, the author used dual microphone arrays and record the original microphone array, and the waveform processed signal by the conventional beamformer, and the processed signal by using the suggested spectral mask. And in figure 9, as we can see that the energy of microphone array, the processed signal by the NVIDIA conventional and the proposed method, and we can see that the proposed method can save the original useful speed component and reduce the speed distortion, and increase the speed quality in the signal to noise ratio. And the author used two methods, NIST STNR and WADA SNR, for calculated the signal to noise ratio. And thanks for the attention. And now I want to introduce another paper.
All right. So before you present the paper, and I would like to ask the following question. So these experiments related to the microphone sensitivity and other parameters, and how can they be applied in the field of linguistics? So how can you see the way it will be applied in linguistics?
Thanks for the question, and I think it's very interesting question. The microphone array may be used in linguistic problem. Microphone array may be used as front-end speech processing for suppressing background noise and increase the speech quality and speech intelligibility of a phrase or sentence. And the next is linguistic algorithm process process. I think that, and thanks for the attention.
Thank you very much, and you are welcome to present another report.
Thanks for the attention. And then in the next, I want to introduce another spectrum map which used in MVW formers. And the suggested the spectrum mass, the idea of spectrum mass is based on the estimation of a priori SNR, and the spectrum mass is derived in the following equation. And in reference 26, an estimation of signal to noise ratio is derived by this equation. And however, another scholar proposes a modified the property of surrounding environment, that is the coherent, the coherent function of useful signal, or the coherent function of observed microphone rays. And therefore the author proposes using the spectrum mass as the following in the figure 6. And now we can see from figure 9 the energy of microphone array and the comparison between NVIDIA conventional beamformer and the proposed spectral mass using spectral mass, and the increasing of the signal to noise ratio. And thanks for the attention.
Thank you very much. Any questions? Thank you for your interest in our report. Pani Alataran, I see she is absent. Well, let us make stop, make a little pause, and well, at 14:45, begin, make a pause and continue at 14:45. Is there any objections? No objections. Okay, let us stop here, and we shall continue our work as it scheduled by the program. You can stay without disconnecting.
You're muted.
Oh, sorry. Dear guests and participants, we continue our workshop on computational linguistics, and I would like to invite Vasil Starko to present the report on feminine personal nouns in Ukrainian, dynamics in a corpus.
Thank you very much. Can you see my presentation slides?
Yeah, sure.
Great. So this is the research that I have done with my colleague from UKU, Olena Sinchak. And our goal was to look at feminine personal nouns in Ukrainian and to see how their use has changed in the language. And for this, we used corpus data. We used the GROK corpus, the General Regionally Annotated Corpus of Ukrainian, as it best fits our research needs. It has grown substantially and now has 1.9 billion tokens or 1.5 billion words. It is lemmatized and part of speech tagged using a large electronic dictionary, morphological dictionary of Ukrainian, Vasum. For our research, we selected newspaper texts. The reason is that newspapers react most dynamically, the fastest to any social changes. So if you want to track any recent trends in the language, newspaper texts are the go-to style. So we built a number of subcorpora using journalistic style and selecting one particular year. And this slide shows the sizes of those subcorpora. From 2000 to 2022, the journalistic subcorpora. And we analyzed feminine personal nouns in these subcorpora to study the dynamics of their use. In order to know which feminine nouns are new or older, you need to have a reference dictionary. And for our purposes, this is the Web Dictionary of Ukrainian Feminine Personal Nouns, which was published in early 2022. It is corpus-based. It has 2,000 headwords, 36% of which are not recorded in other dictionaries. So it gives a really nice snapshot of the feminine personal nouns in Ukrainian as of early 2022. It's available at our dictionary portal, rtu.org.ua. You can see, you can search using a feminine form or a masculine form, and you can see the various feminine forms corresponding to it. You can see the results of survey and so on. So this is our reference dictionary, and then we needed to establish a baseline. And for this, we chose feminine nouns in sports. This is a domain where feminine derivatives are well established in Ukrainian. And so we selected 96 nouns of this kind, taking them from Basum and creating a CQL lemma query. CQL is corpus query language that you can use to combine several or dozens or hundreds of lemmas into one query and study them as a group. So this is what we did here, one CQL lemma query, and these are the results that we obtained across our journalistic subcorpora. As you can see, there are some fluctuations over the years, but there is no clear trend, either upward or downward. There's a spike here in 2005, after which there's a general decrease in the frequency of these feminine nouns, probably due to the fact that newspapers cut down on their news, on their sports sections as sports news became covered by other media. But anyway, there are fluctuations, but no clear trend. And then we looked at a really large group of feminine occupational titles, 744 items in this group, and 2/3 come from Vasum. So these are more established or well-established lemmas, and 1/3 are new words which are not lemmatized in the corpus. And because of that, we had to construct 2 CQL queries, one for lemmas and one for unlemmatized words. And then we added the results, the frequencies, and this is the picture that we got. On the y-axis, you can see the relative frequency in hits per million. And you can see that until the year of 2016, the relative frequency of this whole group of occupational titles stayed pretty much the same, between 200 and 300 hits per minute. And then starting from 2016, the curve turns upward. There's a steady increase in the frequency of these occupational titles, reaching its peak at 2021. There is a slight downturn in 2022, probably due to the fact that we added a a lot more different texts in 2022 in the Grok corpus. So the text composition of the journalistic subcorpus for that year is different. It's more diversified. There are many more media outlets that are included. But anyway, the trend is there, and it's a pretty dramatic trend, and we can see that the shift occurred around the year 2016. Now, you may say that maybe these are the same occupational titles, but they just started being used more often because women received more media coverage in that period. And to test that hypothesis, we looked at lemma variety. And we saw that actually the number of different lemmas from that group increased over the years. There is this growing trend across the years, but it turned upward dramatically starting again from 2016 and 17. So not only the frequency of the overall frequency increased, but also the lemma variety increased. And you can see a really dramatic leap in 2022, where more than 500 different lemmas are used, which is pretty significant because it's more than 2/3 of the whole set. Another large group that we looked at includes war-related feminine personal nouns. These are the nouns that denote women in the military and performing related functions. The group consists of 124 items, which we took again from our dictionary, the SUM, and from the web dictionary of Ukrainian feminine personal nouns. Combine all of them into one CQL word query. So we're searched for words here, not for lemmas. And we can see that quite predictably, a large uptick in the frequency of these nouns occurred in 2014 when Russia invaded Ukraine and started the war against Ukraine. And then after 2 years, the media outlets seem to have lost interest in the topic, and you can see that frequency dropped sharply. And then again in 2022, with the full-fledged war of Russia against Ukraine starting, the frequency went up again. So you can see clearly that the external factors, the war, has influenced the frequency of use of these nouns. And then we focused on several particular cases. On the left, you can see the plot, the frequency plot for Prezidentka, which means female president. And until 2015, there were just a few occurrences over the years. And then you can see a slight uptick in 2016, and the frequency really took off in 2019, growing exponentially, really. So some might say that, because there were several women in the presidential offices in Europe and beyond around this time, this may be the cause of why the frequency of this feminine derivative increased so sharply. And again, to test this hypothesis, we looked at how one person was referred to across the years in our subcorpus. We chose Alexandra Koval, who's a public figure, and she is the organizer and president of Lviv's Book Forum, the largest book fair in Ukraine. And then in 2018, she became the director of the Ukrainian Book Institute. Anyway, she received media coverage across the years. And so we grouped together all the masculine forms that were used in reference to her and all the feminine forms. And you can see that until 2017, the masculine forms predominated. There were just a couple of feminine forms recorded in the corpus in reference to her. And then the point of near equilibrium was reached in 2018, after which the feminine forms clearly dominated. So this graph tells you that even when referring to one person across the years, there was a major change in the way masculine and feminine forms were selected. And that change in her case occurred around the year 2018. And two more frequency plots for two models. This is where we studied two different models, which are productive models used to create feminine derivatives. One is ending in znavitsa, such as religia znavitsa, religion scholar, and then the other one is ending in lohenia, such as pathologia, pathologist, female pathologist. And again, you can see a similar picture. There were very few occurrences until 2016 or 17, after which the derivatives built using these models really took off and their frequency sharply increased. And we also studied new feminine personal nouns in Grok, comparing the recorded cases with this web dictionary that I talked about and selecting those that are not described in that dictionary. And we looked in particular at the productiveness of different models, and the picture we see is a familiar one. This is the same ranking we obtained using dictionary data previously. So the three most common models are the ones ending in ka, itza, and enya. However, remarkably, the model with the suffix its has become more productive relative to the other models. You can see here that 868 derivatives were created with using this model, which comes very close to the most productive one with the suffix ka. Another phenomenon that we observed involves competition. There are cases when several feminine derivatives are competing for one spot, so to speak. And this table gives a little overview of three such cases. So there are several forms that are used in the corpus to refer to a female analyst, female historian, and female mathematician. And you can see that the winners and the losers have already emerged. So there are some forms which predominate already in the corpus, and there are some that are used very, very rarely. The asterisk forms are the ones referring almost exclusively to children, to teachers, sorry, and they are colloquial and have sometimes an emotional charge. So to conclude, the present corpus study of Ukrainian feminine nouns is the largest to date. We have found unprecedented upward dynamics of these items in newspaper text over the past 7 or 8 years. This is when this tectonic shift in their usage occurred in Ukrainian. And it was shaped by social factors such as the increasing representation of women in various domains and enhanced media coverage and gender sensitivity among media outlets. And it was also expedited by major external events, the Revolution of Dignity and Russia's war against Ukraine. We have observed a competition among several derivatives, feminine derivatives, and the winners and the losers are already emerging, which is great because the language is already taking shape in this new territory. And we also see the need for better lexicographical description of these feminine nouns in Ukrainian. Thank you for your attention.
Thank you for your interesting linguistic report. And I would like to invite the participants to ask questions, if any. All right, Vasil, I would like to ask you. So, which form of the noun analyst would be correct in terms of Ukrainian grammar, in your opinion? So, at the beginning, I saw different variations of the word analyst in Ukrainian. But for feminine form, which one will be correct?
Okay, I'll bring back this slide where you can see female analyst, and according to corpus data, Analytica is clearly dominates over 400 occurrences. You see, this is an area of the language that is just taking shape. It has not been really codified. I mean, the official standard dictionaries probably don't include these terms yet. So you can't say this is the correct one and this is the wrong one. Actually, our focus in this study was more descriptive. We wanted to see what is actually used in the corpus, how people write about women in different areas, different domains. So it's not about right or wrong, it's about which is more frequent, which is less frequent. And in the case of an analyst, Analytica clearly predominates. Some people use the more conservative form, Žinka analytic, and then there are two losers in this competition. As you can see, analytics have almost no occurrences in the corpus.
Thank you. Any more questions? Right, then I would like to give word to Valerie Busse or Christine Strauss to present the report Metaverses Virtual Reality and its Impact on the Buying Behavior, an empirical study. There is no such participants, unfortunately. Well, and I would like so I'd like to present give word to Vitaly Karasov or Olena Levchenko to present the report Anger, Conceptual Metaphors in Literary Texts by Oksana Zabushko and Alina Pahutyak.
Hello, everyone. Yeah, let me share my screen right now. Okay. Okay. You see my screen?
Yes, we can see it.
Okay, so the topic is Anger, Conceptual Metaphors in Literary Texts by Oksana Zabushko and Helena Pahutyak. My co-author is Olena Petrivna Levchenko, Department of Applied Linguistics, Lviv Polytechnic National University. So in contemporary linguistics, it is widely recognized that metaphor is one of the distinctive features of idiomatic expression, and examining the process of metaphorization in literary texts is not only valuable for comprehending the artistic techniques employed by writers, but can also shed light on the cultural and social values of both a particular linguistic personality and the linguistic community as a whole. Well, the study examines how the concept anger is verbalized and metaphorized in literary texts by Oksana Zabushko and Helena Pahutyak. The analysis is based on a subcorpus of text from the GRAC 16 database with linguistic material that was extracted using SQL queries. And the theoretical framework for the analysis draws from the approaches to metaphor interpretation proposed in cognitive linguistics. And the objectives of this research is to identify and examine the metaphorical expressions of anger in literary works of Zabushko and Pahutyak, utilizing a corpus-based methodology. And to accomplish this aim, the study employs several analytical techniques and procedures including statistic criteria, conceptual analysis, and others. The investigation of the conceptualization and metaphorical representation of anger in the Ukrainian language is like significant field of inquiry, as anger is like universal human emotion that significantly influences individual and social behavior. Anger is an affective state that arises from feeling of dissatisfaction, indignation, or a sense of disrespect for one's dignity. Upon analyzing the verbal expressions used to convey the concept of anger in the text of Zabushko and her contemporary Pahutyak, as it was mentioned before, it is observed that there is no significant difference in either the frequency or the quantity of the expressions as indicated in table. So the relative frequency of the verbal expression anger in the text of Oksana Zabushko and Helena Pahutyak are 0.003 and 0.005 respectively. It should be emphasized that this difference in the frequency of occurrence is like statistically significant, right? So as you can see on this slide, right? Based on the analysis of the attributes of the verbalizers of the concept of anger using structural model adjective plus noun or and verb plus noun, we found such results that Zabushko anthropomorphically conceptualizes anger as a being with genuine, righteous, holy, and noble attributes. Well, the metaphorization of anger as an aggressive creature is frequent, like anger is an aggressive being. For example, anger shouted, anger choked. Zabushko's literary works feature isolated cases of the conceptual metaphors. Anger is a boiling liquid, like anger boiled, and anger is a container, like anger was found. So on the next slide, you can see the context. For example, and nothing triggers such outbursts of righteous anger in Judas. He even stamps his foot. If we talk about Pahutyak, Helena Pahutyak frequently utilizes metaphors to represent anger as a dynamic and evolving phenomena. This metaphor, like, they portray anger as a process like that involves various stages, like emergence, suddenness, and growth ability to either encompass. And metaphorical expression featuring attributes such as incomprehensible anger, expressed anger, displayed anger, they are also commonly encountered. So all of which portray anger as an abstract concept. Also, Helena Pahutyak employs such models of metaphorization to represent anger as secret, anger as light, anger as liquid, anger as an action. So you can see also the context for this metaphorization, for example, firstly to drive a fly, secondly for balance like a cat, and thirdly to express anger, or her eyes flashed with anger. So we also investigated some verbalizers. The most frequent was indignation. So the indignation in Zabushko's text is swelling, patriotic, immense, like sincere, anachronistic, righteous. So, and we differentiated between the models in Zabushko's literary text: indignation as an object, indignation as a storm, indignation as a boiling liquid. If we talk about Pahutyak, then in Helena Pahutyak's texts, a metaphorical context with an adjectival component of, for example, gloomy, indignation emerges. So here indignation is metaphorically represented as natural phenomena. Additionally, two metaphorical contexts with verb components of cause and engulf portray indignation as personified, with the model of indignation as a person, especially like actor in this case. Also, you can see the context for Zabushko's text. For example, I remember the first day of my Maidan, October 20, Wednesday, like conversion at hairdressers. For the first time, I came out of my underground and heard the people there swelling indignation in the air, but still subconsciousness, right? And the example of Pahutyak, as it has happened many times before, he was filled with sympathy for these animals and was gloomy indignation towards people. The findings demonstrates compounds featuring components of both indignation and anger may serve as indicator of idiostyle when contrasting texts authored by Zabushko and Pahutyak. Nevertheless, the hypothesis necessitates examination using materials from other literary works. Also, if negative emotional states exhibit a considerable number of phraseological expression, the text scrutinized by Zabushko and Pahutyak exhibit numerous metaphorical expression, like collocation documented in phraseological dictionary. Also, we found also we've distinguished between models, like in Zabushko's literary text, anger as an elevation in temperature, anger as an increase in size, also anger as fire. On the other hand, in Pahutyak's text, we've distinguished between such models, anger as loss of balance and anger as an organ. Also, for example, on the next slide, you can see the examples. I'm not gonna read that. Also from the Pahutyak's text, we found also interesting phraseological units. So, in conclusion, I'd like to say that the analysis of the metaphorization of the concept of anger in the works of Zabushko and Pahutyak demonstrates the multi-dimensional dimensionality of the concept. Also, anthropomorphic conceptualization are the most frequent direction of metaphorization of anger in both authors' texts. But Helena Pahutyak's texts exhibit a more diverse range of metaphorical expression for anger compared to Zabushko's text. And phraseological units with the component devil denoting anger are most frequent in the text of both authors. Also, the noun anger is statistically significant and can potentially be used as a mark of idiostyle in the works of Zabushko and Pahutyak, although further researchers is necessary to confirm this, as I mentioned before. Thank you.
Thank you very much. Oh, well, we have questions. Valery, you're welcome.
Yes, thank you for the report. I have a question. When you were talking about the anger that's compared to an object, storm, boiling liquid, etc., did you refer to your own expert cognitive analysis, word by word, or you made some statistical correlations between anger and other words, and how did you make those statistical correlations? What semantic fields did you have? How did you compare the words?
Well,
how
basically,
did you ascribe this metaphoric
well, basically, I found the derivatives of the anger in the corpus using SQL queries, right? And based on the database, based on the words, I made like the analysis, right? So as it was it is known that like cognitive linguistics embrace the idea that the idea that metaphor reflects a part of the way people think. So I sorry, could you repeat the second part of the question?
Yeah, the question is, did you did it manually, or you had pre-arranged set of words and you just the computer counted it and found it?
Well, I did it using the statistical students criteria. Yes, so it was made by it was manual, but with like computer tools. So I didn't program it. If you meant that.
Thank you very much. If you mind, I will contact you after the conference because I'm working on angry texts, sad texts, beautiful texts. I've created a topology of text that and have dictionaries inside that may be helpful for you. It's in English and Russian, but it may be applied to Ukrainian, I'm sure. Thank you so much.
Any more questions? Well, Vitaly, my question as a linguist, so I used to work in this field when working with the concept fear. The concept denoting some feelings can be implicitly expressed. For example, his eyes filled with blood. He began shivering. Did you? What's your opinion in this respect? Non-explicit means of expressing the concepts.
Yeah. Like non-explicit. Well, so it's really interesting to investigate and to classify such concepts with the parts with the concepts too. And I believe that like it takes like much time, and it takes like more thorough than for example, if I so there are a lot of like concepts, there are a lot of metaphors that are in our mind, like that are in our mind, yeah. But there are, from the other hand, there are a lot of that, for example, we've never heard about that. So, and for example, we have to take more time to see through the prisms of the world's of the world, right? So yeah, if I
all right, thank you.
Thank you.
What kind of collocations did you consider where the concept is expressed? What kind of collocations?
Well, like noun plus
noun plus another part of speech, anger plus verb or something like that.
Yes. Like anger plus verb, yeah.
Mm-hmm. Yes,
anger, so basically it was two structures that I've used.
So right, so have you?
You mean example?
Well, you can. I mean that for example, to shiver with anger, for example.
Yeah.
Locations or with verbs, for example.
I see. I see the point. For example, like anger shouted, anger demanded, anger choked, anger boiled, or like we have also like genuine anger, well, holy anger, noble anger, righteous anger. It basically from the Oksana Zabushko's text, right? And in Pahutyak's text, if we talk about like, for example, anger plus verb, like expressed anger or displayed anger, or if we talk about like adjective plus anger, like incomprehensible anger, yeah.
Thank you very much for your interesting linguistic report, and I wish you success in future researches. Maybe you will carry out complex research using corpus-based instruments.
Thank you very much.
Well, and the next report is a method for solving quantifier linear equations for formation of optimal queries to databases by Andrei Kozyrev and Igor Shubin.
Good day, everyone. Can you see my screen? Okay. So I'd like to present our research on the topic of method for solving quantifier linear equations for formation of optimal queries to databases. Nowadays, the rapid development of technologies determines the high rate of method development for creating intelligent systems for various purposes. Currently available intelligent systems are able to perform functions that were previously considered to be done exclusively by humans, like prove mathematical theorems, translate text from one language to another, diagnose diseases, and perform many other functions. Intelligent systems are often based on information models, which are representations of knowledge and data that can be used to support intelligent decision-making and problem-solving. An information model defines the structure, content, and behavior of information in a particular domain and provides a framework for reasoning about the information. So there are several areas that study intelligent systems, like data modeling, machine learning, natural language processing, and knowledge representation. So the problem the common problem is that in various computerized industries, such as medicine or manufacturing, solving these trends is a complex and challenging task that requires careful consideration of the specific domain of knowledge, the available data, and lack of the methods and techniques used to represent and to reason about that knowledge. For example, in an automated computer system, which includes a person as its organic link, the main form of information transfer is solved by documents containing a significant amount of textual information. So computer modeling of text processing allows automating many types of human intellectual activity. And the basis of automated computer system is automated information systems, the purpose of which is to automate the processes of information accumulation, search, and generalization. The effectiveness of automated information system is recognized by the ability to process unformalized or weakly formalized information. To improve and formalize knowledge in various fields, we often use mathematical approaches. One of the effective and universal mathematical methods for describing information is the algebra of predicates and predicate operations. This language is easy and convenient to describe various formalized information, specifically to form queries in databases and model human activity. The algebra of predicates can also be used in conjunction with linear quantifier equations to model an efficient way to query knowledge bases and represent knowledge in a specific domain. Linear quantifier equations are mathematical expressions that involve quantifiers such as for all there exists. So our work focuses on studying linear predicate operations in algebra, including the properties and application methods for describing patterns and solving quantifier linear equations. Additionally, providing algorithmic implementation of the method for solving quantifier linear equations based on the algebra of linear predicated operations, the formal operators and linear logical operators and methods of solving logical equations. So we consider in each case that the database in the main approximation can be considered as an automaton of type L with U query and U result. Representation of the database in the form of an algebraic structure is shown to be useful in various cases. For example, in cases where it is necessary to determine the deviation of compositions and decompositions of databases. So the model is designed to provide a solution to complex problems by processing input data about the system being modeled. It utilizes a system of logical equations to determine consistency and eliminate non-essential features, resulting in an array of solutions to the problem. So this approach is particularly useful for problems that may have multiple solutions or require a thorough analysis of the system's characteristics. By leveraging the power of logical equations and semantic features, this model provides a flexible and comprehensive solution to a wide range of problems. So let's see the example given, which illustrates the possibility of using the theory of linear logical operators and methods of solving the quantifier predicate equations. Suppose that the database contains information about 4 factories that produce some details for cars. We assume that we have 4 factories and the existing factory part relationship is described by the following binary predicate P1. The next problem is to obtain information about which plants produce part D1, and the corresponding predicate revealing this requirement is written in the second form of P2. So as a result, the predicate P3 corresponding to the sought information is denoted by a quantifier equation of type like there exists some D for part P1 and P2 equals P3. the solution of this predicate equation is obtained from the solution of the corresponding operator equation A times X equals Y. The matrix of operator A has the following form, and the matrix of and the vector X as shown below, and the result of the operator of the multiplication of A by X, we get the vector Y 1 0 1 0, which meaning that the part D1 is solved by factors F1 and F3. Now, let's suppose that we have a more complex problem, namely to calculate which factors produce parts for a specific car. So, as we can see, the relations on the screen, and we can build the following quantified predicate equations that corresponds to these conditions. The next, we can display the system in the form of a single equation. Then the quantified predicate equation corresponds to an operator equation of the forms B times T equals X. So we transformed it. Now we can get the result of logical operator T, which has the matrix form built previously on the binary predicate K1. Therefore, the predicate equation corresponds to the operator equation of the form like A times B times T equals X. So next we can transform it we can simplify it to the form F times T equals X, and by taking the superposition of these operators, we get the result of X. So the next, having this result, we can, for example, calculate which factories manufacture parts for car C1. So the corresponding logical vector T has the form 1 0 0 0, and as a result of calculation, we get that the manufacturers of car C1 are factories 1 and 2. In conclusion, I'd like to say that the developed algorithm offers practical application in various fields, including automated information systems, information search systems, logical expert systems, and object recognition and classification. The results obtained from this work suggest that the method can be utilized in the creation of linguistic support for automated information systems, solving logical problems in databases and expert systems, and addressing issues related to object recognition and classification. The algorithm can be improved in the future by studying more specific areas of the practical applications of the developed algorithm in each of the mentioned fields. Okay, so that's it for now. Thank you for your attention.
Thank you. Any questions, please? All right. So, let us. It is scheduled coffee break, but I would like to propose to listen one more report and then go for a break. So, Oksana, Melnichuk, Ivan Bechta, and Maria Tkachevska. I invite one of you to present the report, Pearson Correlation Coefficient in Studying the Meaning of a Literary Text.
Okay, thank you very much. Good afternoon, dear participants of the conference. Our presentation, our research is devoted to Pearson correlation coefficient in studying the meaning of a literary text, prepared by Oksana Melnichuk, Ivan Bechta, and Maria Tkachevska from Lviv Polytechnic National University and Vasil Stefanik Prokopethian National University. This research constitutes the engagement of Pearson correlation coefficient in studying the meaning of a literary text through the statistical textual analysis, correlation of words as part of speech under the limits of the structure of a literary text or narrative, including subject, action, and object, and description. Pearson correlation coefficient is used to establish ties between the most frequent words in corpora and correlated words in terms of part of speech categories. One of two corpora, possession or romance, will be used to illustrate the results of the study, but the study was conducted using two corpora. The idea of textual analysis involving its structure is not new. It starts in structural linguistics, flourishing with a number of formal models. Linguists defining literary text narrative as a sequence of events or actions paid attention to a core structural element, an action expressed by verbs. They argued that action is always connected to the one who does it, a doer or subject expressed by proper nouns or pronouns. Then the action is directed on an object, common noun, and may be described and evaluated. Such theoretical background gives rise to the following structure of a literary text or narrative, so-called SAO structure, including subject, action, and object, and sometimes description or evaluation. Nowadays, quantitative data analysis available in computer processing make it possible to evaluate objectively meaningful components of textual structure, which reveals the meaning of a literary text in connection to the parts of speech. The aim of the article in terms of the literary text analysis and applied linguistics is twofold. First, to establish Pearson correlation coefficient between frequent words in corpora. They are elements of SAO structure, and correlated words. They are meaningful components of literary text using Voyant 2 web browser. And second, to define weighty correlated parts of speech categories based on their quantity. The meaning of a literary text narrative is a multidimensional and complex phenomenon. The properties of a literary text include macrosemantic structures, which map onto surface structures through parts of speech, nouns, verbs, adjectives, adverbs, and adjectives. General meaning sentence.
Oksana, sorry interrupting you, but do you move your presentation, because we can see only first frame.
Okay, I move it.
But it doesn't.
It doesn't work. Okay.
Yes.
Does it move?
No, it doesn't.
Doesn't. Well, does it move in such a way?
Yes, it does.
Okay, let it be in such a way. The aim and slide number 6. So, part of speech significance in literary text. The central role of verbs is acknowledged by the fact that literary texts are a particular kind of action discourse, that is, discourse which is interpreted as a sequence of action denoted by verbs and their properties. The verb having a radiative power is the center of much of the semantic and grammatical information in the clause. The verb is like a node or a link, and other words, part of speech, are supposed to be connected to it. Being a necessary element to build a meaningful statement, a verb is the node of a sentence or a group of words. From a semantic point of view, a verb expresses an action made or undergone, in other words, a change of state from A to B. The significance of noun, proper nouns, common nouns, or pronouns is expressed by subject or proper nouns, who performs an action, and object, common nouns. Proper nouns in a literary text play the role of markers of time and space. Without them, the reader loses a sense of certainty in time and space or of textual fabric. Proper names contain several types of information. Their value is formed as correlation with the object, and in other words, the value of a proper name is identical to established information about the object. Proper names also have the property of a particular reference as well as the massive number of connotations. Adjectives alter, clarify, or adjust the meaning contributions of nouns. They can plainly align with nouns, forming complex constituents and linking with other elements to form a noun phrase. At a general level, adjectives gain this capability in virtue of two main characteristics, one of which is semantic and the other is structural. On the semantic side, they suggest properties. On the SAO structure side, they are able to function as evaluation and description and may tie up with nouns. The result of this combination is a new property, thereby providing a finer shade of meaning of a literary text narrative that is not possible using the noun alone. Two methods were employed to the present study. The first is quantitative textual analysis to define word frequency using ON2 web browser. And the second is the study of Pearson correlation coefficient generated by ON tools in terms of part of speech related to SAO structure. Pearson correlation coefficient is a measure of linear correlation between two sets of data. It is the ratio between the covariance of two variables and the product of their standard deviations. This measure, it is the measurement of the covariance. The coefficient always has the value between -1 and 1. Here we have the results. We have the word frequency. The analysis of Pearson correlation coefficient starts with the analysis of word frequency. The most frequent words in corpus possession remains said, like, know, mod, ash, think, thought, little, Roland, and time. Further, we group frequent words according to part of speech categories: verbs, proper nouns, common nouns, and adjectives, adverbs. The diagrams show the most frequent proper nouns, figure 1, verbs, figure 2, common nouns and adjectives, figure 3, in 10 textual segments. The diagrams, including relative frequencies, demonstrate that verbs are distributed evenly in textual fragments, except the verb know. It provides verb importance in providing SAO structure. The verbs form a kind of action scheme, a balanced saturation of the literary text. On the contrary, the quantity of proper names is sharply different in each textual segment. The object time is presented in each textual segment having approximately the same quantity, and the evaluation or description little is the highest in the second textual fragment. Here we have another table where we show calculation of Pearson correlation coefficient. It's only the fragment of the table. It is very long because it comprises all of the frequent words. So using Pearson correlation coefficient in corpus possession elements, we define the values of correlation and significance of frequent words in a corpus. 15 correlations for each word. The fragment of the table demonstrates the first column, which contains the frequent words. The second column shows related words, and the third includes values of correlation, and the fourth, the values of significance. We have the values of correlations and values of significance here. The next, frequent words grouped as subject, action, object, and evaluation correlate with all of the research part of speech categories: proper nouns, common nouns, verbs, adjectives, and adverbs. Figure as it is in the figure. Each element of SAO structure draws or correlates with different quantity of part of speech categories. The highest figures of part of speech categories are concentrated in action verb, which attracts mostly nouns and verbs. Part of speech which constitute object or evaluation are not so numerous. It grounds the hypothesis that the action is a core element of a narrative, because narrative is defined as a sequence of action, and that is why action is central and verb is central, and verb attracts mostly nouns and again verbs. To make the results more accurate, we depicted correlated part of speech categories as percentage. Figure 5 demonstrates that the subject, frequent proper names mostly correlates with proper nouns. Action or frequent verbs with common nouns and verbs, object with verb, and evaluation with common nouns. Proper nouns and adjectives do not have high percentage while correlating with subject, object, and evaluation. We see approximately the same quantity of correlated part of speech categories in both corpora and under SAO structure. It means that the Pearson correlation coefficient does not characterize the author's style, but contributes to meaning, exposing in textual structure. So the conclusion is, the resulting picture is one that raises a number of noteworthy questions about the centrality of verb and nouns meaning in relation to action and subject in literary text under the scope of statistical textual analysis. Taken together, these results suggest that the Pearson correlation coefficient is a significant quantitative index in the study of the meaning of a literary text through the statistical correlation of words, which forms the basis for the semantic analysis of a literary text and the SAO structure. The research proves the idea that centrality of the verbs embodied in action and connected to object in a literary text in spite of the author's style. By carefully examining the data, it was found that the most frequent words in each corpus correlate with words as definite part of speech, mostly with nouns and verbs, to a lesser extent with adjectives. Calculation of the Pearson correlation coefficient of the words in a literary text might be addressed in future studies involving both quantitative aspects, for example, Spearman correlation, and qualitative parameters of a literary textual interpretation or cognitive modeling. Thank you. Thank you for your attention.
And thank you for your report. So please, Valery Belyanin, you're welcome. Valery, please.
Yes, thank you for very interesting research. I have a question. You mentioned that the author's style is important. Have you seen the difference between the texts according to the amount of verbs they use or adjectives they use? For example, action detective stories where a lot of people are doing a lot of things like chasing someone, killing someone, and texts which are more descriptive, like about the thoughts, emotions, and feelings. And how can you define them? How can you prove that maybe statistical difference between those types of pictures
Thank
of the
you.
world?
Thank you very much. It's a very interesting question. To tell the truth, just starting the research, it seemed that while working with wide frequency, it would be clear everything about author's style. But when we started the research and when we began to compare frequent words, they are mostly the same from author to author, in spite of the genre of the text even. So when we are talking about frequency, first of all, we are talking about the textual structure. And to research idiolect or author style, we need we need deeper research. We don't need to take frequent words by vice versa. We need to look some peculiarities. But when we look only as a frequency, first of all, we see verbs in every text, in just every fiction text. And they are different, denoting maybe we may judge only the psychological, maybe when we see such words as know, see, or we may say about some perception that this text is mostly psychological and connected with perception. When we see go, come, and so we may say that this text mostly shows the action. To judge also a style or idealect, we need take into account not only frequent verbs, just we need to analyze all of the verbs of the text, all of the adjectives in this text, and as a result we will get more clear picture of the author's style. But this picture, when we take only frequency, just generally we see the general construction, just general construction of narrative and the structure of narrative.
Thank you very much. I also think that just the statistical approach may not be enough, because the impression from the text, the weight of the words, the position of some adjectives when they appear in the text, it's not just an adjective, it's very important for the author, for the story, for something. So we need to add something to statisticals, or go from some conceptual model, for some cognitive model, as you said, to the statistics, and then see how it works, this correlation. I would like to share with you my works on models of the world and fiction I've written for books, and thank you very much for your research.
Thank you.
Thank you. Any other questions? It seems to me that there is no more questions. Okay, let us make an interval, and we continue our work at 16:15. At 16:15. Okay. So now it's interval, and we shall join the session at 16:15.
Okay.
This database creation scripts, then show some software tool development results, software tool usage experiments, and complete with the discussion and conclusion on our paper. So the problem is almost all applications, all software systems you may know for today are using databases and database management systems as data manipulation services to storage and manage large data collections to make them persistent and secure. But dominating agile practice of software development do not assume engineers focusing only on database design or any other specific field. It brings extreme flexibility to development teams, but database design usually belongs to the scope of software engineers who are responsible for server-side programming. And therefore, lack of special skills and experience could lead to database design mistakes that lead to time and money expenses when software project evolves to later stages. And when software requirements are formulated, then database entities and relations are usually captured in the form of business rules, some brief and precise text descriptions of the considered domain. And therefore, in this study, we propose computational technology and software tool for business rules translation into database creation scripts to reduce time and cost at the development or maintenance stages of software engineering projects, because it's known that expenses could rise up to 100 times in compared to early stages of analysis and design. And in our paper, we propose business rules to be given as controlled language structures, as according to the scheme demonstrated here. It's obviously of limited grammar and complexity. And we also propose a deterministic finite state machine to process business rules and token by token extract entities and attributes from these business rules. And this is possible exactly because the usage of controlled language structures. As for the example for preliminary extraction of entities and attributes, input data we need for our tool is the business rules given as a sequence of sentences according to the described structure. And using the deterministic finite state machine here, we can extract entities and their attributes and start building something which then will become the database schema design. As shown here, for a sample set of business rules, we got already extracted entities and attributes. Then next challenge is to detect relationships between entities, and we propose to do it using shared attributes, using primary keys in parent entities and foreign keys in child entities, as the relational theory says. The algorithm we propose is too large, so it just doesn't fit a slide. But of course, it's presented in the full paper. But to describe it verbally, I can say that to detect relationships, we propose to check all pairs of entities and search for intersections of their attributes. And here, this algorithm assumes that entity, which firstly mentions the common attribute, will be considered as parent entity and other entities as child. And using this algorithm to the example introduced in the previous slide, we can complete it with detected relations between the entities. And one more complicated task here is to detect data types for attributes using only their names. And here we propose to use Spider NLP dataset created and supported by Yale staff and students by the Yale University. And this dataset includes 166 databases with different tables and attributes that in total cover 138 different domains. And using metadata descriptions of database tables from this dataset, we prepared a set of attribute names and their data types and processed them using association rule learning a priori algorithm, which allowed us to get for this particular examples and for other examples we used for experiments with software created later, allowed us to suggest suitable data types using only attribute names And for example, here, this approach is still limited because some attribute names may not exist in the data set we used for association rule learning. For example, here for course number and number credits attributes, it suggested default text data type. So we also propose to use alternative way to adjust data types for detected attributes using naming conventions. Because business rules are still formal structures and attributes mentioned in business rules could be really close to future names of database columns. And we propose to define different sets of keywords to extend the association rules algorithm and check how attribute names match naming conventions. For example, like using prefixes or suffixes for number type attributes, possible timestamp attributes, or possible Boolean attributes like shown here, and adjust for this particular example, these columns previously mentioned as text to be now of number domain. And in general, the proposed computational technology includes 4 steps, starting with the extraction of entities and attributes using deterministic finite state machine, detection of relationships, primary and foreign keys in the extracted entities and attributes, data types suggestion using a priori algorithm with spider NLP data set plus naming conventions, and finally the step where the data definition language SQL commands are generated to provide SQL scripts. This computational technology includes deterministic finite state machine and algorithmic model, which consists of 3 algorithms: relationships detection algorithm, attribute data types suggestion algorithm based on association rules, and data type suggestion algorithm based on naming conventions. And the software tool created based on the proposed approach for now is a command line tool, which takes several arguments as some other command line utility software. It's the name of business rules text file we use as input, name of the output SQL scripts file, which will be created then after processing, and the name of target database management system. We are focusing on relational databases, which is obvious from the beginning, and our tool is capable to generate scripts that follow Oracle database, MySQL, Microsoft SQL Server, and PostgreSQL syntax. This is confirmed by using SQL Fiddle service to check the compatibility of output scripts with different versions of these database management systems for Oracle, for MySQL, for SQL Server, and for PostgreSQL. So our software produces SQL scripts deployable to popular database servers. And as the example for those set of business rules introduced in the beginning of presentation, we put it into a text file, and on output we received the SQL scripts ready to be deployed into one of these database servers, which represents such a structure of entities, attributes, and connections between them. Obviously, SQL scripts we obtain require adjustments if it comes to real database for some website or application, it requires adjustments of data types and constraints such as null values or not null values, or default constraints, or adding some keys or indexes to tune performance, or unique indexes to follow some business requirements. And as for performance evaluation, we have processed large collections of entities and attributes definitions given as business rules, as text here. And these calculations prove our solution is capable to process really large volumes of business rules and generate syntactically correct SQL database statements for future adjustment and deployment. And the mean time, for example, of processing for 100 for database of 100 tables is like 1 second and 8, as shown here on the slide. And to discuss the business rules, we proposed solution which successfully translates business rules into DDL code, and DDL scripts are successfully tested for database schema generation using different database engines, and the performance of the tool is demonstrating a reasonable processing time. However, of course, this proposal has its limitations, because we first of all assume the usage of only limited grammar and structure for input business rules statements. And detection of relationships could fail if the keys are not mentioned as primary and foreign keys as common entity attributes. So basically, they don't match by their names among different business rules. However, the second limitation is not so critical, because it's actually a common practice in relational database design to name key attributes as we consider in our approach. Similarly for primary and foreign keys, because among 166 databases present in examined data set, 163 databases, which is 98% demonstrate the same approach for the names of primary and foreign keys. And to conclude, the proposed technology includes deterministic finite state machine, proposed algorithms, and SQL code generation toolkit. And in the future, we see it as extended by algorithms that can detect constraints in business rules, and to develop some web-based prototype for the usage by some people without technical experience, and to improve user experience for this software. So thank you very much for your attention, and I'll be glad to answer your questions.
Thank you very much. Dear participants, dear guests, your questions, please. No more questions. Well, thank you for presenting your interesting report. Andrei, thank you very much. Well, and next, the next report is predicate layering method and its application in the system of artificial intelligence by Irina Kirichenko, Ganna Pronyuk, Natalia Gizeleva, and Gleb Tereshenko.
Good afternoon, I'm Anna Pronyuk, and let me allow to present our work for you. One moment. Oh, sorry, I don't understand. What is this? Yes, it's okay, yes?
Yes.
Okay. Okay, dear colleagues, your attention is invited to the work I predicate clustering method, etc. by Anna Pronyuk, Natalia Gesleva, Irina Kirichenko, and Gleb Tereshenko. Yes, sorry, I don't understand what is so quickly. It's maybe one pushing of the button and each terrible speed. Okay, sorry. I will try to do this very gently, but I not promise about this. Okay, sorry. In recent years, great attention has been paid to the development of new methods for parallel information processing. Practically all exciting approaches are based on the concept of decomposition, and composition in one way or another. Be it programming, database, neural networks, and so on. Therefore, the development of the new theoretical methods of decomposition is highly promising and interesting direction in algebraic logic. Allow me to present this our methodology sequentially. In predicate algebra, comparator identification is widely used, which is a type of the indirect identification. A comparator K, standard approach, is a device with M inputs and one output, and this output is the binary reaction of the comparator. And the comparator determines whether its input signals are in a given relation, we call this K or not. This method is designed for investigation objects with input signals that are inaccessible for direct measurement. The subject of such identification is often the human intelligence. So I don't know what happens. Let us consider the main concept that will help us generalize the method of comparator identification to a wider class of predicate. It is known that any predicate I'm afraid I don't know. Sorry, I can't do something. Okay, and it is known that any predicate E in some Cartesian domain is present for any X and Y as an MA indication forms as forms 2. And in predicate algebra, any equivalence predicates and only they can be represented in the general form with a suitable choice of this set of domain and function. And above it has been shown that a pair Nphi, their characterizing function determines an unique equivalence predicate too. And however, thus every equivalence predicate unequally determines that this pair domain and function. It turns out no. There exist different pairs that define the same equivalence predicate. And the property formulated below specifies the necessary and sufficient conditions under these two pairs determine the same equivalent. And from this is state 1 and text in slides, it follows that if the equivalence predicate E can be represented as second forms, then it can also be represented as the third result. It follows from statement that if the predicate is represented by two different methods, we can specify these for the unequivalence predicate E. It is known that the comparator identification method describes an object up to isomorphism. Essentially, this means that comparator identification, just like direct identification, provides an unique description of any object up to notations. To solve problems of comparator identification in important questions is the issue of isomorphisms of equivalence characteristic function. And in this work, I'm afraid to sorry. In our work was shown that in statement 2, that property means that following: two different descriptions of the same identifiable system P, those input signals are defined on non-intersecting domains, always coincide up to strong isomorphism. So they coincide up to the designations of input signals of our system P described an on-the-flight notation system. The substance of these and other statements, what we proved in our work, means that the behavior of predicate in form 2 of any system is fully determined by the action of our function f in vice versa. This means that a comparator identification method is described for mathematically describing subjective phenomena. The behavior predicate P of the subject allows determining the set of images as well as the intellectual function of human perception, understanding, recognition, uniquely up to isomorphism. The questions arise next. Is there another general form of a binary predicate, and what is this form? Undoubtedly, there must be some general expression that gives some binary predicate. To answer for these questions, consider the following concept. Let us consider an arbitrary binary predicate P and seek a presentation for it in which the comparison of the value of two corresponding functions f1 and f2 is carried out using a simple predicate in some sense. This predicate should replace the equality predicate in formula second. In order to obtain the required form of the predicate, let us first consider several important concepts. Is statement these, and this statement show the generalization of the theorem of accompanying equivalence for predicate of arbitrary. Next, I've all times I don't know what is this. And this is theorem, it's the main theorem on the general form of a binary predicate of the first order. And this is expression 5, represents the general form of a binary predicate. Surjection f1 and f2 are called the characteristic function left and right of any predicate P. Predicate L is called the image of predicate P under equivalence E1 and E2. Theorem first can be extended to the case of arbitrary of n area predicate. By representing the predicate in its general first order form 5, we have achieved that the maximum amount of information carried out by predicate about the relationship between the elements of set domain A1 and A2 has been transferred to function F1 and F2, while the comparator bears minimal border. The following property, statement 4, states that by these comparator identification methods, any n object can be identified exhaustively. This means that even in the most general case, the depth of analysis of objects using the comparator identification method is not inferior to that of direct identification method. Identification of human intellectual activity using this scheme opens the way to a mathematical description and artificial reproduction of such important aspects of the mind for machine intelligence as perception, understanding, recognition, and other. A two-layer decomposition of the first-order predicate is called its decomposition into characteristic function and images according to its general first-order form. The most important case for practice is the decomposition using accompanying equivalence. There is also a case of using equivalence nested in accompanying equivalence. Next, it was previously mentioned that any equivalence predicate can be represented in the form second, whereas F is selection. The questions arise: what form will the predicate, type of this predicate, take if any mapping is used instead of selection F? To answer these questions, the general form of the predicate needs to be slightly modified. The following statements provide the requirement modified form of the predicate in statement 5. In this is 6th equation, the predicate F is called the characteristic predicate of the equivalence. It uniquely determines the characteristic function F of the any equivalence. It is important to have a method for construction of the characteristic predicate for any equivalence. So, in conclusion, it should be noted that the general form for the most general case of the symmetric predicate, the quasi-tolerance predicate, has been obtained. If we remove the last hour restriction, the symmetry of the predicate E, the following theorem will be valid. Theorem 2 of the general form of binary predicate of the second kind. The formula 7, which represented the general form of this second order predicate, and this formula can be expressed differently as 8, where the relation dB is a symmetric and reflexive predicate which we define as 9 expression. It should be noticed that in formula 8, H1 and H2 not a function now, but they are mapping, so it's objects of the more general nature than function. In turn, the second order two-layer decomposition of predicate is a representation of the predicate in its general second order form using formula 8. In this form of predicate representation, a certain classifying function appears that assigns name of all sets of variables. This property is very useful in describing the structure of many information object database, microchip design, and other. In the previous section, two types of two-layer decomposition of predicate were considered, the first and second types. Their combination results in a three-layer decomposition, which completes the construction of the method of multi-layer decomposition of any predicate. The first type of decomposition transforms the predicate E into construction fifths, where F1 and F2 are.
Sorry, interrupting you. How much presentation have you?
My presentation has a duration to 10 minutes. I finished maybe. No,
so it's it's time to finish because we it's already 15 minutes.
Oh, maybe. Sorry, because it's maybe a little nervous due to this strange fast version of this. So this is our basic result because it's combination of this is two methods. And sorry. I try to do this a little more faster, and this is decomposition give us possibility to have a scheme representation of any predicate, and this is scheme. If you can see, if parallel preparation of any predicate, because this is converse function f and g give us this is parallel presentation. Next, it's example how we can apply this in construction of standard adjectives in Ukrainian language. We study how we can represent, due to this decomposition, the analysis of ending of any adjectives. So I can do this faster, and it's only a model of this. At first, we have some restriction of course. X, it's our ending with this G letter. Yeah. After we have some features of these values, it can be stressed or unstressed letter, or soft, hard, and all this. After we constructed the 15, the domain of introduction variables as formula 11s. After the same value, we constructed the domains of definition of all our variables, where we construct all this function, and all this function. No, it's all the slides is about type of our ending of our adjective, all properties about them you see, and the last, it's reconstruction of all our letters in general form. So all these formulas from 11 to 16, because you have this presentation, form a model of the flexion of adjectives in the Ukrainian language. It is evident that processing such a system of education is extremely difficult, and it is necessary to further decompose of original morphological predicate. What is why we propose to use our principle of decomposition of any type of predicate to a lot of human relation. And similarly, it is possible to describe the declension of the all adjectives, nouns, pronouns, and numerals, prefix, suffix, as well as contractive of verbs. The result obtained in this work can be found broad application in various areas of human activity, and the most maybe promising direction is the creation of new generation computer based on the principle of parallel information processing. The scientific problem of development algebraic method for predicate decomposition for the formal analysis of information processes, particularly for the formal representation of natural language, text semantic, has been solved in this work. And summary of all this is theoretical approach in this slide. It's our conclusion. Okay, thank you so much for your attention, and sorry for loading.
Never mind. Thank you for your interest in our report. Well, are there any questions? No more questions. Okay. And the last one is discourse of user comments in the system of media influence on public opinion to the application of critical discourse analysis in the study of social networks by Maria Butyrina, Victoria Shabunina, and Oksana Tul.
Okay, I'll share my screen.
Yes, we can see your presentation.
Dear conference participants, we are going to present you discourse of user comments in the system of media influence on public opinion to the application of critical discourse analysis in the study of social networks. Nowadays, communication in social networks is becoming more intense. The high level of discursiveness of social networks, their role in replicating messages and catalyzing influences determine the interest in this phenomenon in the field of discursive studies. In our study, we focused on the network space of Great Britain, as the UK keeps the third place in the world and the first in Europe for the average number of social media accounts per person. The fact is that 74% of the UK residents access their news through online networks, including social media. At the same time, Facebook is the leader in the world social media platform ranking and has more than 2.9 billion of monthly active users. In market conditions, traditional media like The Guardian are forced to use social media platforms and their resources as they can quickly find their target audience there. The users of different social strata engage in dialogue with each other on online discussion platforms offered by the media and discuss some important political and social economic issues. In general, the analysis of comments makes it possible to reveal the content of public opinion on a particular issue. To our mind, the comment discursive field doesn't so much represent reflections on the basic media messages as it points out the free communicative existence of some statements or the participants of the communicative event. Some posts on The Guardian's Facebook page served as empirical material. The task was to find out the peculiarities of the perception of journalistic materials in social media. We applied critical discourse analysis to the study of social media. During the critical discourse analysis, we determined the following characteristics: intertextuality of comments, transitivity, epistemic, axiological, spatial, and temporal modality. We also paid attention to the relevance of the comment to the topic of the material. 4 posts from different thematic blocks were selected for analysis. This made it possible to demonstrate the patterns of reception of social network discourses in various social spheres. In order to prove the hypothesis of a high level of discursiveness of social networks, we'd like to show the use of critical discourse analysis on the example of 2 high-profile political messages. These posts resonated with community members, so they had a large number of comments. The first post is a link to the speech of British Prime Minister Boris Johnson regarding the Russian-Ukrainian crisis. This post had about 1,000 comments. The vast majority of them showed a content shift towards current British issues and concerns. The corpus of the comments indicated a high level of intertextuality of the monologue that was spread around Boris Johnson's speech. Among the comments, one could find appeals to historical facts, mentions of personalities, and reminiscence of mass culture objects. All of them illustrated the perception of the Ukrainian theme in the light of criticism of the political career of British Prime Minister. Under the post, there were the most frequent references to the images of Winston Churchill. In 15% of the comments, there were ironic remarks about Boris Johnson's inaccessibility to the level of the legendary British Premier. Among the intertextual elements, we could also find references to the legendary conqueror of the world Alexander the Great, the serial killer Harold Shipman, and the comedian Benny Hill. The comments had a high and medium transitivity level. This indicates that digression from the subject was accompanied by a reference to personal and collective reflections. Epistemic modality of 70% of comments was represented by position mode. Statements containing manifestations of ignorance and knowledge were equally divided. Each group of statements accounted for 15%. That discourse was critical and directed against the current Prime Minister. Accordingly, about 70% of comments had a negative axiological modality, 25% neutral, and 5% positive one. Diachronicity as a feature of temporal modality was observed in 40% of comments. Spatial proximity of comments was 80%. The second post is also about the war in Ukraine. It's a link to the article Roger Waters cancelled gigs in Poland amid roll over Ukraine war comments. This post caused a wide response and gained 2,300 comments. At the same time, comment branches formed an active discourse space. There were about 230 replicas. The post explicated the phenomenon of so-called culture of cancellation. In this case, we are talking about the act of cancellation of Roger Waters, a co-founder of the progressive rock band Pink Floyd, because of his unacceptable position on the war in Ukraine. The post was actually a reflection on a reflection, that is a response to the reactions of the Poles who demanded Roger Waters to be declared persona non grata in their country. Critical discourse analysis of the corpus of the comments revealed their high relevance to the topic of the main message. In any case, 100 of the comments developed the topic of the media message. The comments had a low and medium sensitivity level. It means that 90% of the comments pointed to the hero of the narrative, and 10% of the comments were imperatives or ironic recommendation to Waters. This indicated that the topic didn't cause personal reflections, and the responses mainly concerned the hero of the post as a third person. This indirectly indicated the commentator's focus on the topic. Epistemic modality concerned the expression of users' opinion in 94% of cases, and only 6% of the comments demonstrated knowledge of the extra-linguistic peculiarities of the situation. The comments had a heterogeneous ecological modality. This indicated a certain polarization of the community in political assessment. In our opinion, accusing voters of pro-Russian views included the modes of negative modality. It made up approximately 70% of the comments. In this case, intertextuality was provided by appeals to the communist ideology and the corresponding sympathies of the musician. It was noted that 10% of narratives showed a neutral attitude toward the actor of the material. They took us beyond politics and actually leveled the scandalous resonance of Waters' political action. About 20% of comments had a positive modality. It's characteristic that they were mainly evaluative, cognitively simplistic, and stereotypical. About 10% of comments had intertextuality. In addition, we singled out biographical references that directly related to Roger Waters and political allusions that expanded the context of negatively connoted comments. In 94% of cases, synchronicity was the main characteristic of temporal modality. It means that the commentators were on the time frame of the discursive event. In 95% of cases, spatial modality also indicated a clear stabilization of comments within the discursive space of the media message. We can compare the results of critical discourse analysis of these high-profile political messages. So, CDA confirms the fact that social networks are an active discursive space which on the one hand expresses public opinion and on the other forms it. Both user-centrism of social networks and the activity of network users causes self-organization of community members carrying on a polylogue. This could be seen on the example of the Guardian Facebook page. The Facebook effect described by Donald Kirkpatrick is complemented by the discursive uniqueness of the field of readers' comments that spread around media messages. Their specificity is that they can demonstrate different levels of relevance to the topic of the key post, from complete compliance with it to its absolute autonomy, when the discourse of the basic post doesn't correspond to the discourse of the comment. This characteristic depends on such parameters of the media message as its topicality, transitivity, spatial and temporal proximity to the recipient. CBA has brought to light the fact that the agendas of the media and public news don't coincide with each other. Under these conditions, readers use media messages only as a starting point for branching out comments that match their personal and group interests. Then to CDA, we have found that the same topic, depending on the temporal context, evoke different responses from users. So, critical discourse analysis made it possible to reveal the peculiarities of the reception of journalistic materials in social networks and to prove their high level of discursivity. This is indicated by the autonomous branches of comments under the main media post. We believe that CDA is a heuristically valuable research tool for studying network communication in its various manifestations and patterns. Thank you very much for your attention.
Thank you for your report. Any questions, please?
May I have a question?
You're welcome.
Yeah, it's a very interesting research, and I would like to ask you about some technical details. Did you use some automatic processing of commands, because it's a large of data?
Thank you very much for your interest in our topic. We didn't use any algorithm. We did it by hand.
Okay, I understood. Thank you.
Thank you very much.
Any more
No
questions?
more questions.
You have another question? Yes, please.
No. This is all.
Oh, well.
I don't have any
Thank you. And any more questions? No more questions. So our session is over. Our computational linguistics workshop is over. Thank you to all the participants and guests for finding time to prepare to present a report and take active part in different discussions. So I wish you many successes in your future researches, and I hope that next year we shall gather once again, and I hope it will take place in a peaceful time and peaceful situation, and as well in offline mode, because verbal response is also important between intercommunication. So thank you very much. Till the next conference.
Thank you very much.
Thank you very much for organization conference, and Yevgeny, thank you very much for your foundation about ethical.
Thank you very much.
Thank you very much.
Thank you very much.
Thank you. Bye-bye.
Bye-bye. Thank you.
Bye.